everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. And everybody, let me know in the chat box if I am completely visible and audible to all of you. Everybody in the chat box, am I audible? Am I visible? Okay, so today I am going to take Haloalkanes and Haloarenes. It is a very important chapter, and you are going to see that so many questions, right, predictable questions are asked in JEE Mains as well as advanced, right. So basically this makes the basis of all the reactions that we are going to do in the next chapters that we have already done, that amines, carboxylic acid, alcohol, phenols, ethers, right. So it's a very interesting chapter and it is highly demanded by you kids, right. So that's why I thought that let's take this lecture again on this channel, right. Okay guys, if I am completely visible and audible to you, then let me know in the chat box. Yes, I am visible. Perfect. Ma'am, will you teach concepts? Yes, definitely I am going to teach you concepts as well as JEE Mains, JEE Advanced previous year questions, right? Okay. Okay guys, so everything will be done in detail. Today only we are going to complete the full chapter, right? And I'm very excited for this chapter, everybody. Are you all excited or not? Let me know in the chat box. And then I think I should wear my specs because that is very necessary, right? Okay. I can't see the Josh in the chat box. Part 1 or part 2, this is the only part, right? Here we are going to complete the full lecture, full chapter today itself, right? Okay, so you just need to sit here maybe for 3 hours, maybe for 4 hours, but I promise you one thing, once you have finished this chapter with me, you will score like full marks in your JEE Mains. And here I'm also going to show you some questions of JEE Advanced, right? We will again revise this chapter according to JEE Advanced concepts, right? It's not like there will be a very large gap, but yes, the concepts will be same, but the question, the way they ask the question will be little twisted, right? So I'm going to show you the sample of that JEE Advanced questions as well, but the mostly the focus is going to be on JEE Mains, right? Okay. Yes, everybody, but it's not like I will not teach you anything about JEE Advanced because there are only few months, right? So we need to prepare for JEE Advanced as well as simultaneously, right? Okay, yes. So now let us start the session without wasting any time, and I hope so you guys are very energetic today and I want to see you guys very active in the chat box, right? Okay, so now let us see this. So starting with the students, so firstly let us see what we are going to do here, right? So firstly let us see what you are going to do in this particular lecture, right? So very simple thing. Firstly, what is haloalkanes? Firstly, we will talk about what is haloalkanes, right? Then we will talk about the preparation, nomenclature, properties. Nomenclature, I won't focus that much, right? Because nomenclature, don't worry, I'll take up one lecture where we are going to take nomenclatures like from full syllabus. Right, there will be one lecture that I will take where we are going to discuss nomenclature from all the chapters, right, so that you can retain that in your head, right. The rules of nomenclature, they are quite similar to each other. That's why only some part of nomenclature we will discuss here. Basic, our main focus is going to be on preparation and properties of haloalkanes and haloarenes. And here frequently asked topic is SN1 and SN2. SN1 and SN2 and other reactions as well, but these two kind of mechanisms, this is the hot topic of this chapter. That's why in detail, like we will discuss a lot of questions. We will discuss in detail what is this SN1, SN2, how you can predict SN1, SN2, what is nucleophilicity, what is basicity, right? All these things we will discuss in detail because this is the most, students find it difficult to understand, ma'am, where SN1 will occur, where SN2 will occur. So we will talk about those things as well, right? Okay, yes. Okay. Lagging, I know there is one, I just want to clear, guys. So there is not lagging because of internet or nothing like that. It's lagging because of there is some default in the system. I am unable to understand that which is that default. I have taken up like full 2 days. I was talking to the IT team regarding to finding out that what is the issue with this studio, but I'm not able to understand that. So that's why you just need to, just adjust today, because tomorrow there is the engineer will visit my house, and they will, solve all the problems, the blinking issue, the lagging problem. So there is something wrong here which I am not able to understand, because I am a chemistry teacher, right? I am not an engineer, right? Maybe you guys can understand this because you are future engineers, but for me it's like totally out of my head, right? So today you have to adjust, right? Okay, will you be able to adjust? I know little bit, like I am looking like a ghost here, right? But little bit you can adjust, right? Okay, yes everybody, yes everybody. I didn't wanted to cancel today's class because of this small issue, right? Because I know that you guys can adjust here. Because if it would have been a very big issue, that I would have, taken a step and I would have just rescheduled the class. But I think you guys can adjust here, right? Okay, yes. Okay, now let us start it. Let us start it, everybody. Let us start it. Let us start it. So the first thing is classification of haloalkanes and haloarenes. This is quite similar to alcohol, phenols and ethers that we have done before. So classification of halogen compounds, first is based on the number of halogens. If you have one halogen in the compound, that is monoalkane. If you have two halogen, that is dihaloalkane. If you have three halogens, that is trihaloalkane. That means halo means the halogen, and mono is 1, di is 2, tri is 3. So based on the number of halogens, you have these classification. Second is based on the hybridization, whether it is sp3 hybridized, it is sp2 hybridized. Based on that, you have two kind of things. One is sp3 hybridized, other is sp2 hybridized, right? One is sp3, other is sp2. If you talk about sp3 hybridization, as you can see here, right, sp3 hybridization always means the sum of lone pairs plus sigma bond should be 4, right? So let us talk about alkyl, allyl, benzyl and alicyclic. So these are the 4 sp3 hybridized things, right? sp3, when you have sp3 hybridized, right? So basically, firstly we need to understand what is alkyl. Alkyl means simple chain like CH3, CH2X. Now here we know that here this carbon is connected by 4 sigma bonds. So what we need to see is the halogen is connected to the carbon, that carbon has 4 sigma bonds or 3 sigma bonds. So it has 4 sigma bonds, that is why hybridization is sp3 and this is called alkyl, right? Okay, now let us talk about what is allylic, right? Allylic means you have double bond, right? Then there is one carbon, then you have halogen. So in this case, complete the number of hydrogens here. Now what you can understand from here, the halogen is connected to that carbon which is having 4 sigma bonds, 2 sigma bonds with hydrogen, 1 sigma bond with this carbon, 1 sigma bond with this halogen. So that is why this is also sp3 hybridized. This is called allylic, like this is called allylic. Now what is benzylic? Anybody in the chat box, what is benzylic? To this benzene, when you have a carbon that is connected to the halogen. Now complete the hydrogens here. Now halogen is connected to that carbon, which is having 4 sigma bonds, okay? That is 1, 2, 3, 4. Now we don't need to see the halogen. Just see halogen is connected to that carbon which is having 4 sigma bonds, that is why it is sp3 and this is called benzylic. So benzylic, allylic or alkyl, these three are sp3 hybridized, right? These three are sp3 hybridized. And what is alicyclic? Alicyclic means simply cyclo, to a cyclic chain, right? Halogen is connected, right? To this halogen is connected. Again, this will have, for example, I talk about alicyclic. Okay, let's talk about alicyclic somewhere here. right? Let's talk about alicyclic, right? Somewhere here. Okay. Now, alicyclic, if you say alicyclic, now to this alicyclic, for example, you have a simple cyclohexane and a halogen is connected here. Now see one thing, this is alicyclic and a halogen is connected here. Now you will say, ma'am, there are only 3 sigma bonds. Array, where is this hydrogen? Hydrogen will also be connected, no, to complete the tetravalency of carbon. So it has total 4 sigma bonds. That is why it is sp3 hybridized. Okay, that is why. Very good evening. Very good evening, students. Very good evening. Now that is, ma'am, give time to write down notes. Prajwal, don't worry, you will get everything on Vedantu JEE English. Right? If I start to give time to, I'll give time to take the screenshot and I will also share the notes with you. Right? You can make the notes after the class. Right? You can do the revision and make the notes yourself. If I give time to make the notes, then this lecture will not be 3-4 hours. This lecture will be 12 hours. Right? Okay. So I don't want to waste your time on that. Right? Okay. So now this is going to be sp3 hybridized. Now tell me, are you able to understand this? Right? No. I have just started the lecture. Anand. Right? Okay. So these are sp3 hybridized. If you talk about sp2 hybridized, like 2 main things about sp2 hybridized are vinylic and arylic. Right? So let us talk about sp2 hybridized here. sp2 hybridized, that means it should have 3 sigma bonds. Right? It should have 3 sigma bonds. Right? So first one is vinylic. In vinylic, to this double bond only the halogen is directly connected. Right? And here, if you complete the total number of hydrogens, it will be like this. Now understand one thing. Halogen is connected to that carbon which is having 3 sigma bonds. This carbon is having 1 sigma bond with hydrogen. Right? If you write it this way, this is having 1 sigma. This one is pi bond. Right? So it is having 3 sigma bonds. That means it is sp2 hybridized. Right? That means it is sp2 hybridized. Okay. So this is your vinylic. You can write here, this is your vinylic halides. If you talk about aryl means when you have a benzene ring, but here to this benzene ring directly the halogen is connected. That is called aryl. Now if you see here, the carbon that is connected to this halogen, that means this carbon is having how many sigma bonds? 1 sigma, 2 sigma, 3 sigma, this one is pi. That means it is having 3 sigma bonds, so it will be sp2 hybridized, right? It will be sp2 hybridized. Got it, guys? Again, I am showing you this sp3 hybridized, allylic, benzylic, and this is your last one is alicyclic, right? This one is alicyclic, and this is your simple alkyl, right? So these are the 4 important things that are sp3 hybridized, and this is sp2 hybridized. Main is benzylic, that is frequently asked. Allylic, we will do also reaction based on this. Then you have vinylic, then you have aryl. This is where students are confused. In vinylic, to the double bond directly halogen is attached. In allylic, to the double bond, the carbon next to the double bond, the halogen is attached. In benzylic, the carbon next to the benzene, halogen is attached. But in aryl, directly to the benzene, halogen is attached. Okay, understood? Clear? Right? Okay, shall we move ahead? Right? Okay, guys? Okay. Now, let us see what is 1 degree, 2 degree, 3 degree halogens. Right? So, if you talk about this halogen, and this halogen, how to determine whether it is 1 degree halogen or it is 2 degree or it is 3 degree halogen. So understand one thing, guys. So if you talk about this halogen, you don't need to see the halogen. Ma'am, halogen is connected to 1 carbon. Array, always halogen belongs to group number 17. always it is going to form only one sigma bond, right? It will have always, halogens will have always 3 lone pairs around it, right? 1, 2, 3, 4, 5, 6 and one sigma bond will be formed with some other atom always. So you can't say that how many bonds halogen is connected to. You need to see the carbon to which halogen is connected. Now halogen is connected to this carbon which is further connected to 1, 2, 3 carbons. That is why it is 3-degree halide, right? That is why it is tertiary halide. Now this halogen is connected to a carbon which is further connected to only 2 carbon. That is why it is a 2-degree halide. That is why it is a 2-degree halide. If you talk about this halogen, it is connected to that carbon which is further connected to only 1 carbon. Only 1 carbon. That is why it is a primary halide. That is why it is a primary halide. Okay. Now, if you miss that, okay, ma'am, this is so simple, I don't want to learn this, then when I show you the questions, you'll be like, ma'am, now to ma'am, it is difficult because my basics are not clear, ma'am, right? So that's why these things are important for you. Next is nomenclature, right? Now let us see the nomenclature here. Let us see the nomenclature, guys. For the nomenclature, right, firstly I am telling you, see, nomenclature I am not going to do in detail in this lecture, but ma'am, will you do this? Yes, I will do. I'll do the nomenclature, a specific different lecture on nomenclature of all organic compounds and functional groups and polyfunctional, spiro, bicyclo, all the things we are going to do in a separate lecture, right? Okay, here just I am giving you an overview of the nomenclature, right? So see, nomenclature, we know that 2 things are there. One is IUPAC, other is common name. This is common name and this is IUPAC name. So if we talk about the common name, like Chintu, Mintu, Bintu is the common name, right? But Charendra, Mahendra, Bahubali, right? These are the IUPAC name that are registered in the school. But at home, we call it Golu, Molu, Sholu, right? That is the common name, right? So here common name can be some rules oriented, or it will be anything, like it can be anything that is preferred by the scientist. But IUPAC name follows a proper rule, right? But generally we say that common names are alkyl halide, right? For example, you have chlorine, that will be for example this thing. Now here alkyl chain is pentyl. Not pentyl, it's propyl because it is having 3 carbons, so propyl, and this thing is bromide. So it will be propyl bromide, right? It will be N-propyl bromide. Why N-propyl? Because N means normal. N means normal. So basically you have 3 things. One is N, one is iso, one is neo. One is neo, right? One is N, one is iso, one is neo. So if you talk about these 3 things here, then you should know one thing, that N means normal. Here it will be a normal chain, right? It will be a normal chain. There is no branching here. No branching here, right? If you talk about iso, in this case, to this carbon, any carbon, you should have 2 methyl group. You should have 2 methyl groups, that is called iso group. When you have 2 methyl groups, that is called iso group, this kind of group. And neo means when you have 3 methyl group. When you have 3 methyl group, that is called neo, right? That is called, otherwise it can be anything. After this, it can be anything, right? So this is your iso group, this is your neo group, right? This is iso, this is neo. This is N, iso, and this is neo group, right? Now let us see the common name here, right? If you talk about the common name of this thing, this carbon is having 2 methyl groups. That is why it is iso group. So it is regarded as isopropyl because overall the number of carbon atoms are 3. In 3 means propyl chain. But it is having 2 methyl groups. That is why it is called isopropyl, right? So it is isopropyl, and what is the halogen? It is chlorine. So it is chloride. What about this one? Here it is called isobutyl. Now can you tell me why it is called isobutyl? Because in this case, to this carbon you have 1, two methyl groups. That is why this thing is suggesting is that it is a iso group. This thing is suggesting us that it is a iso group. But here can you see one more thing, that it is having total number of carbon 1, 2, 3, 4. So it is isobutyl, right? Isobutyl chloride. So when you talk about the common names, what is important? Knowing which is iso, which is neo. That is important for you, right? Okay. Connected to each, then it is neo or iso. You are saying this one. If here CH3 is connected, here CH3 is connected, then it will be neo, but neo 1, 2, 3, 4. Neobutyl does not exist. Neobutyl is nothing. Anything such as neobutyl will not exist. That is not there in chemistry, right? Neo starts from pentyl. Ma'am, why? It's just IUPAC. I don't know why, but yes, it is the scientists only. They have told us that iso will start from propyl, but neo will start from pentyl. है ना? Neo will start from pentyl, right? Okay, and here you will have a chain which is having a halogen. Maybe it is having CH2X, then it will be isobutyl. If it is having C, then X, it will be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Isohexyl, because total number of carbon are 1, 2, 3, 4, 5, 6. Right, so it is isohexyl. But if CH3 is connected, then it is not neo, it will be regarded as tertiary. Right, it is regarded as tertiary. Right, why it is regarded? For example, instead of this carbon, you have this thing. You have this thing. Now it is not neo. Now it is tertiary because halogen is connected to that carbon which is having 3 carbons. So that is why I am saying neobutyl will not exist. Then how can you differentiate between neobutyl and tertiary? Right? Okay, understood? Understood, guys? Are you able to understand that thing? That I am saying that there is one more thing as secondary and tertiary. Secondary and tertiary. That is why here you can write it will start from isopropyl and so on, and this will start from neopentyl and so on. Neopentyl and so on. This will start from isobutyl, isopropyl and so on. Right? Okay. Methyl in the first position is connected with another. I am asking if the substitute group of methyl in the first position is connected with the another methyl on the same side. I am not able to understand that. If the substitute group of methyl in the first position is connected to another methyl on the same side. I am not able to understand your question, Prajwal. I am not able to understand your question. Right? So this was about iso and neo. Right? IUPAC naming, though, guys, we can easily do that. Just number it the longest chain and you will have the IUPAC naming. That is 1, 2, 3. So it is 1 bromopropane. Here it is 1, 2. So it is 1. It is having 2 chloro. Wait a minute. 1, 2, 3. It is 2 chloropropane. What about this one? It is 1, 2, 3. 2 methyl, 1 chloropropane. On the first position you have chlorine, on the second position you have methyl. Okay, understood? So IUPAC naming is very simple, but common name is important for you. Right? Now let us see some structures. Now I think it will be clear to you. Prajwal, I think from this table things will get clear. Right? From this table things will get clear. Let's not focus on IUPAC naming. Why? Because I am going to do that in a different lecture. Right? IUPAC naming of all organic compounds. Let's focus on the common names. Right? Let's focus on the common names. Here you have CH3, CH2, CHCl. I am going to draw the structures here. CH3, CH2, CH, CH3, Cl. Now students, you need to tell me, is this a normal chain? Is this a normal chain? Can you see any branching of alkyl chain here? Can you see any branching of alkyl chain here or not? Can you see any branching of alkyl chain here or not? Everybody. Now, We can't see any branching, so it will not be iso, it will not be neo, right? It will not be iso, it will not be neo. But can we say it is a normal butyl chloride? Normal butyl chloride will be like this. After 4 carbons, you should have chlorine on the last position, on the last carbon. So it will also not be normal butyl. That is why the name here, that means chlorine is connected to that carbon which is further connected to 2 more carbon. That is why the name is secondary butyl chloride, right? That is why the name is secondary butyl chloride. Okay, understood? Secondary butyl chloride. Now let us see the next one, that is CH3 thrice. CH3 thrice, I am going to write it here only. This is secondary. CH3 thrice. Guys, please focus here. Please focus here. Right? This is a major problem of students. They are not able to understand which is secondary, which is tertiary, which is neo, which is iso. Right? Okay, I could have started just from your preparation, but I am starting from this phase. Right? Okay? Okay, Rahul. Okay, sure. Now, this is the second compound. Now see, you can see branching here. And can you see that on one carbon you have 3 methyl groups. On one carbon you have 3 methyl groups. That is why this will be neo. This will be neo. And I told you that neo will start from pentyl. So can you have 1, 2, 3, 4, 5 carbon? Definitely. So it will be neo pentyl. The group is neo pentyl. Right? The group is neopentyl. If you ask, ma'am, why neobutyl will not exist? If you talk about this group, if you talk about this group here, if you talk about this group CCH3, CH3, CH3, and this is Br. Right? So see, in this case, it is, you will see, ma'am, this is also neo, so it should be neobutyl. Neobutyl does not exist. Reason why? Because this halogen is directly connected to the carbon which is having the branching. This halogen was not directly connected to the carbon which was having branching. Right? When the halogen is not directly connected, then we can say it is neo, but when it is directly connected, then it will be tertiary. So here carbon is having 3 more carbons. The carbon that is connected to halogen is having 3 more carbons. That is why it will be tertiary butyl. It will be tertiary butyl. Okay, that will be tertiary butyl. Understood this thing or not? Everybody understood this thing or not? It's a major mistake that students do. It's a very big mistake that students usually do. Right? Okay, now I think this also we have done. Then you have CH2, this is so very simple. I don't even need to draw the structure. To this double bond, chlorine is directly connected. That means it is vinyl. To the double bond, then it is connected to a carbon, then the halogen is connected. That means it is allylic, right? That means it is allyl bromide, right? Now, here what you can see, to this toluene, you have chlorine position. But now we know that if you talk about this position here, just a second, if you talk about this position here, then we know that to any benzene ring, right, if any group is connected here, then according to that group, this will be ortho position, this will be meta, this will be para. So it will be ortho, this will be meta, this will be para. Oh my Prabhu, right? So that will be ortho, meta, para. And here, as you can see, here this is the ortho position, this is the ortho, this is meta, this is the meta, and this is the para position, right? So here it is on the ortho position, that is why it is orthochlorotoluene, right? This one, benzene is connected to a carbon and to that carbon the halogen is connected. That means it is showing the benzylic group here. This is the benzylic group, benzene and then the carbon, then the halogen. This is the benzylic group. That is why we have named it as benzyl chloride. Right? That is why the name is benzyl chloride. Okay guys, now everybody in the chat box, what about bromo? Array, I was just telling you about the chains. You can see after here, secondary butyl chloride. So you want to write the full names, and I can write the full names also. I was just telling you about the alkyl chain. Secondary butyl, here it is chloride, here it is chloride, here it is bromide, here it will be bromide. Okay? Yes, everybody? Is the naming clear to everybody? Which is secondary, right? This is secondary, this is tertiary, this is neo. How to represent neo, right? How to represent neo? Neo will start from neopentyl. Iso will start from isopropyl, right? Iso will start from isopropyl. Everybody tell me, is that thing clear or not? Is that thing clear or not? Everybody in the chat box, is that thing clear or not? Next one is the nature of CX bond, right? The nature of CX bond. Now see, this is your C and X bond. Halogens are very electronegative. We know that along the period, the electronegativity increases. That means group number 17 halogens are very electronegative. That is why they are going to have this partial negative charge, and carbon will have this partial positive charge. That is the reason they are very reactive, because of the electronegativity difference, right? Now, if you talk about the RX, that means CX bond, where X can be fluorine, chlorine, bromine, iodine, right? This is fluorine, this is chlorine, bromine, and this is iodine. Then this we will talk about inorganic chemistry, where we know that down the group size increases. Down the group size increases, right? So let us see the bond length, because down the group the size is increasing. The size of this fluorine, this halogen is increasing, right? It is increasing. So bond length will also increase. That is the reason the bond length is going to increase down the group. As you can see, the bond length is increasing because the size increases down the group. Then you have CX bond enthalpy. Now see, if something is very you won't say large, it has a very big length, right? So you have a big stick, it will be easy to break that stick. If you have a very small stick, right? For example, I am having two bonds here. I am having this bond, right? Okay, I am having this bond, I am having this bond, and I am having this kind of bond, right? Here bond length is large, here bond length is small. So it will be very difficult for me to break this. As you can see, I am trying my best, but I am not able to break this. But for this large length, it is easy for me to break this, right? Easy for me to mold this also. So that is the reason, as we go down the group, right, the bond length increases, the bond enthalpy will decrease. We require less energy to break that bond, and hence the bond enthalpy is decreasing here. Bond length is increasing, bond enthalpy is decreasing here, right? Okay, then you have dipole moment. If you talk about the dipole moment here, right, that means dipole moment means the polarity difference. We know that down the group electronegativity will decrease, right? Electronegativity will decrease, right? Along the period, electronegativity increases. Down the group, electronegativity decreases. That is the reason less polarity will be observed in the C and X bond. Hence, the dipole moment will decrease down the group. That is why it is decreasing. As you can see, down the group it is decreasing, and here it is little bit, yeah, it is decreasing only. So I'll just write it like this. Okay, it decreases. Like this is approximately little bit increase here because of the fluorine size. Like that is because fluorine is very small in size, but they will not ask you this. This is a question of inorganic chemistry. They will not ask you about the dipole moment of C and X bond here, right? Okay. Now, next thing is, let's talk about the electrophiles and nucleophiles. Now see, electrophiles are electron loving species, right? They have love for electron, they have love for electron density. Now, if you love electron density, opposite attracts, no? In life also opposite attracts, here also opposite will attract. If you like positive things, right, that means you are negative. If you like negative things, that means you are positive, right? Opposite attracts. So here it is electrophile, that means more electron density. more electron density it wants, right? So that is why it will have less electron density. Itself, it will be less electron density. Means that we can say that it will be a cation, right? If you talk about the charge here, the charge, it will be a cationic species, because a cationic species is electron deficient. You can write here, it is electron deficient, right? It is electron deficient. It is electron deficient. That's why it is attracted towards more electronic cloud, right? So it is electron deficient. That is why it is cation. If you talk about neutral, if you talk about the neutral electrophiles, then these neutral electrophiles should have vacant orbitals, right? So they should have vacant orbitals, vacant d orbitals, right? So like we say FeCl3, ZnCl2, SnCl2, they have vacant d orbitals. That is why they are electron deficient. Or they should have incomplete octet. Incomplete octet also, students, that means they should not have 8 electrons in the outermost shell. Like you have BeCl2. It has how many electrons? It has 1, 2, 3, 4 electrons. It has 6 electrons. It also has 6 electrons. It also has 6 electrons. It has 4 electrons. That means the octet is not complete. They don't have outermost, they don't have complete 8 electrons in the outermost shell. That is why they are electrophiles. Okay. Now, let us talk about what is nucleophile. Now, let us talk about what is a nucleophile. A nucleophile, opposite of electrophile, that is nucleus loving. Nucleo means positive, right? That means it has such a large electron density that it is attracted towards the which is very poor, right? Which don't have the electrons, right? So that is why we can say that it is electron rich species. That means if you talk about the charge here, it will be having a negative charge. That means it will be a anion, right? It will be a anion, polyatomic anion also it can be. Fl, F negative, Cl negative, Br negative, I negative, OH negative, OR negative, right? Why nucleophiles are so important? Because in this chapter, we are going to talk about nucleophilic addition reaction, nucleophilic substitution reaction, where the nucleophiles are going to attack. So that is why this thing is important for you to understand, that nucleophiles are negatively charged species, right? And what about neutral nucleophiles? Neutral nucleophiles should have lone pair of electrons, right? Either they should have lone pair. That means if they have extra electrons as lone pairs, then that means they are electron rich and they will be attracted towards a cationic species, a species which has vacant d orbitals, right? So here that means H2O, ROH, ROR, RNH3, these are the nucleophiles. Or it should have pi bond, right? Multiple bonds it should form. Now, as you can see, this is having a pi bond, this is a sigma bond, this is a pi bond. That is why it is attracted towards the one which is having less electron density. Understood? Yes, everybody understood what is a nucleophile, what is a electrophile, right? Okay. Yes. Rajesh, arey yaar. Rajesh, it's not, I don't like having low quality video, teaching on a video lagging. I think you were not present when I was in the starting only. I told you one thing, that guys, today you have to adjust. I could have cancelled this lecture, but what I feel that teaching you is more important than having like, oh my god, there is little bit glitch, I will not teach today. Oh my god, I have an excuse, I will not teach. I will just take a chill pill and I will relax. That's not the kind of teacher that I am, right? Engineers are working on it. They are going to visit my house tomorrow and they are going to work on this, because guys, I am not an engineer and I am not able to understand what is happening, right? Okay, so you have to adjust today, right? Now, these are the electrophiles and nucleophiles. Is that clear to everybody or not? Is that clear to everybody or not? Right? Okay, this was not supposed to be here. Right, I'll just delete this page. Right? Okay? Yes, everybody? Now let us talk about the preparation methods, right? Okay, let us talk about the preparation methods. Yes, everybody in the chat box. Let us talk about the preparation methods here, right? Preparation of halogen compounds, okay? Preparation of halogen compounds. Now, if you talk about the preparation of halogen compounds, then it is very important that what is exactly the chart, what we are going to proceed towards, right? So, halogen compounds means Rx, right? So firstly, we will see from alcohols, from alkane, right? Then from alkene, right? This is alkane free radical halogenation. Then from alkane, in addition, alkene, this is alkene. By the addition of X2, addition of HX, this is alkane only, addition of X2, addition of HX and alpha halogenation. Then you have alkene, addition of X2, addition of HX. Then you have alkyl halides, halogen exchange reactions. Then carbonyl compound, right? From carboxylic acid, from ketones, from aldehyde, how you can prepare the halogen compounds, the haloalkane compounds, right? So this is a full that we are going to do in next 1 hour, right? Next 1 hour will be dedicated towards the preparation, right? Okay. So now starting with the first thing here from halogens, as you can see here from halogens, what you will do, you will have a specific reagent and you will replace this OH with the Cl, right? Everywhere, whatever halogen you have added here, that will be replaced by that halogen, right? So now let us see one by one what are these methods. So the first method is Lucas reagent, right? First method is Lucas reagent. This is also the test for, this is also test for 1 degree, 2 degree and 3 degree alcohols. If you want to distinguish between 1 degree, 2 degree, 3 degree alcohols, then we use Lucas test, right? Okay. Okay, so students, let me know in the chat box if you want me to end this class. Is this that much of a problem that you're not able to adjust? I'm saying it again and again. Or should I write it over here somewhere? Then it's lagging and I don't wish that it should lag, but what to do? Do you want me to end this lecture today and take class on some other day? Right? Because it will take, see, it will take 1 to 2 days, right? It's totally your wish. If you feel that it's too much lag, that ma'am, we are not able to understand anything, then I can also end this class. Right? Okay? Yes, guys. See, I'm not in like, a very professional technician here, right? I'm a teacher, so I can't solve it myself, right? Continue? Okay, chalo. Okay, then I'll continue, right? Now, here first thing is Lucas reagent. Lucas reagent means that is a test for 1 degree, 2 degree and 3 degree alcohols. So if you can see here 1 degree alcohol, right? 2 degree alcohol, anybody in the chat box, 2 degree alcohol. Then you have 3 degree alcohol, 3 degree alcohol. After Lucas reagent, 3 degree alcohol will give turbidity, that is cloudiness, immediately. Turbidity immediately will be formed, right? If you talk about 2 degree, it will give turbidity after 5 minutes and it will give after heating, after prolonged heating. Then after 5 minutes, maybe 10 minutes, maybe 30 minutes, it will give you the turbidity, right? But in case of 3 degree alcohol, the turbidity is formed immediately. That is how we distinguish it with the help of Lucas test, right? And what are the Lucas reagent? What are Lucas reagent? Lucas reagent are, this is Lucas test. And what are the Lucas reagent? Lucas reagent are ZnCl2 and HCl, right? So anhydrous ZnCl2, HCl, this is the Lucas reagent. It is going to just replace OH with the Cl, right? That is your first test, first reaction. Second reaction is in NaBr, right? H2SO4 and reflux. When you have sodium bromide, you need to have a very strong acid here, right? Can you tell me the reason here? Can you tell me the reason here? See, we know that NaBr with a very, because it is not easily reactive, that is the reason, right? So NaBr, H2SO4 and reflux, then it is going to replace OH with the Br, that is the second reaction. Third and fourth are quite similar to each other. That is, if you have PX3 or you have PCl5, then it will be replaced by X and Cl, or you can say X here, right? But here, when you talk about PX3, the byproduct that is formed is H3PO3, that is an oxo acid, right? But if you talk about PCl5, then the byproduct formed is POCl3 and HCl, right? Then the byproduct formed is POCl3 and HCl, right? You can just write it one thing here, that if you have ROX, right? If you have ROX, right? Okay. ROH, right? This is ROH, right? And here you have, PX3, right? P, and this is X3. You can just write it here. P, this is X3. Now what will happen here? Three products will be formed for Rx, right? Three products. This is just a way to remember, okay? This is just a way to remember this thing. How to remember this thing? This will be Rx, right? 3 Rx plus you will have H3, 3 hydrogens, 1 phosphorus and oxygen 3, H3PO3. Right, this is how you can, remember this particular thing. This is how to remember this particular stuff, right? Then if you talk about the other one is PCl5, then what will be formed? One OH will be replaced by the Cl, and you will have HCl and PCl3 as the byproduct. The byproducts are important here. Okay, the byproducts are important because they can give you a question where they can give the hint, right? So that is the hint. Last one is, fifth one is very, very important. That is SOCl2 and pyridine, right? So now here we are using thionyl chloride, SOCl2 and pyridine. Now basically what is going to happen here in SOCl2, you are going to replace this OH with RCl, and this reaction is called as Darson reaction. Right, this reaction is called as Darson reaction. When you have pyridine and SOCl2, right, this OH is replaced by the Cl. That is called Darson's reaction. Now, one more thing about this one is that you have one more process, one more reaction, and that is called as Reed's process, Reed's reaction. Reed's reaction. But in Reed's reaction, everything is same, but the difference is you have R, that means you will have alkane, I'll say just CH4 maybe, right? Then you will use SO2Cl2. Here you have used SOCl2, this is thionyl chloride. But in Reed reaction, we use sulfuryl chloride, right? So here, because these are quite similar, that is why I'm writing it here. It has no relation with this thing, right? So here we are not making from alcohol. Rather, we are making it from alkane. So it will be CH3Cl. Rest of the products will be same, right? Rest of the products will be same here, right? Understood this, students? So that is your Darson process. But Reed is quite similar, but that is from alkanes, right? Okay. And here we use thionyl, not sulfur. We use sulfuryl, not thionyl, right? And one more thing, this Darson process is preferred, like as compared to all the other processes. The reason is we will have vapors of the byproducts. Byproducts can be, byproducts are vapors only, are already vapors. So that is why pure RCl is formed here. That is why this process is preferred as compared to other processes. Right? Okay. Yes. What is the role of pyridine? So basically that is that helps in the mechanism here. Right? So basically what happens, no? So this HCl that is formed, pyridine is a base. Right? So HCl that is formed in SOCl2 that helps in a mechanism. Right? So when you use the pyridine, then you will have a Darson reaction. If you don't use pyridine, it's not like this reaction will not happen if you don't use pyridine. The reaction will happen, but through some other mechanism. Right? So that is, it just helps in the mechanism. Right? Okay? That helps in the mechanism to speed up the process. You can say it acts as a catalyst here. Right? The mechanism will totally change if you don't use pyridine here. The reaction will occur, but mechanism will totally change here. Right? Okay. Now, the next one is your preparation of halogen compounds from the halogenation of alkanes. So now here we are going to start very, very important things. Right? If you start from alkanes, the first process is from halogenation of alkanes, very, very important. Very, very important. So if we talk about halogenation, right, you will use UV light, right, that is sunlight, and this will occur by free radical mechanism, right, and this will occur by free radical mechanism, right, and this will occur by free radical mechanism. Now, what is the use of this thing and how it will occur? If you talk about the use here, you are adding Cl2, Hmu or very high temperature, sunlight, UV light, it is used here. So, one Cl is replaced. If you replace one hydrogen with Cl, 2 hydrogen with Cl, 3 hydrogen with Cl, 4 hydrogen with Cl, according to that the product will be formed. And what is the process? The process is a free radical mechanism, right? If you can see what kind of free radical mechanism, as you can see here, right? So basically what will happen in this case, just go through the free radical mechanism once. You don't need to remember the full steps of the mechanism, right? Because they will ask you the reactant and the product. For that you need to know the reactivity and selectivity principle, right? Mechanism I am showing you just for the sake that, okay, you should know that what is happening here, right? So here what is happening, the what is going to initiate this process? So firstly, because of the UV light, because of the high temperature, this molecule is going to split into the free radicals, right? So one electron will jump here, other electron will jump here. And now remember one thing, free radical mechanism, it has 4 things. Either you should have heat or electricity. Either you should give it really, really high temperature, that is heat, or electricity, or light, that means UV light or sunlight, or you should use any peroxide here, right? Or there should already be a free radical present here, right? So that is the condition of a free radical mechanism, right? So if you talk about these conditions, we are giving it heat and we are giving it sunlight, either heat, or we are saying that either you give it high temperature or give it sunlight, right? So any of the 2 things you can do. That means the process will initiate, right, and it will form a free radical. Once the free radical has been formed, the process will start and the chain reaction will begin here, right? So this is the initiation process. Then we have the second step is the propagation. Propagation means to continue. Now what will happen? One free radical will form another free radical, another free radical, another free radical. This will start happening. So this free radical is going to come to this methyl, right? Then what it will create, this free radical is going to create one more free radical. That means this bond that you have here, one electron will jump here, one electron will jump here. you will have CH3 free radical, and this H free radical and Cl free radical will combine. You will have H free radical and Cl free radical. They will combine and form HCl here. That is why the byproduct here is HCl. That means that now we have the free radical of the alkane that we had. Now, in the solution, see what else you will have. In the solution, you will have CH3 free radical, right? You will have Cl free radical here also. It's not like only one molecule is going to dissociate into free radicals. No? There is also this one free radical. There will be infinite number of free radical in the mechanism, right? Because we are not talking about one molecule. We are talking about infinite number of molecules, right? So many free radicals, Cl free radicals will be present. So many CH3 free radicals will be present. So what will happen? What will happen? Four things can happen. CH3 free radical can combine with CH3 free radical. CH3 free radical can combine with Cl. Cl free radical can combine with Cl free radical, and hence you will have the formation of these four things: ethane, methyl chloride and Cl2, right? So what can be formed here? Here they are telling you what else can be formed. Firstly, this thing can be formed, right? In the chain termination, you will have the formation of Cl2. You can also have the formation of this ethane. So basically, we are talking that there are so many molecules, so many free radicals will be formed. So CH3 can combine with CH3, CH3 can combine with Cl, Cl can combine with Cl, and hence you will have, in the end, you will have methyl chloride, ethane and chlorine. These will be three things, right? So once chlorine is already generated, then the reaction will go right. Okay? Yes. In free radical, no, here we don't have the formation of carbocation carbon ion, right? Here we have the formation of free radical. Whenever you have this thing, you'll have the formation of free radicals, right? This means that this is a condition of free radical. Carbocation, carbon ion, that will depend on mechanism to mechanism that what we are going to form. But if you have any of these things, then definitely you will have the formation of free radical there, right? Okay, yes everybody. Now let us see the reactivity and selectivity here, right? Let us see the reactivity and selectivity. Very, very important principle now I am going to talk about. Reactivity and selectivity principle. So see, what is this reactivity selectivity principle? If you talk about chlorine, bromine, this is like this: fluorine, chlorine, bromine and iodine. See what exactly is the case. Fluorine is very reactive. The reactivity decreases in this order. This is the order of reactivity. And in these two reactions, we are not going to focus on iodine on fluorine. Reason is because fluorine is very explosive and iodine is so slow that it almost gives us a reversible reaction, right? This is very explosive. That is why we are going to not talk about this fluorine here, right? And this reaction is very slow and reversible. That is why we are also not going to talk about iodine or fluorine here. We are going to talk about these two things here, that is chlorine and bromine, right? Now, as you can see, like from daily life only we can see, if you are very reactive, okay, you are like, okay, you just take decisions like this, okay? You don't give a thought to your decisions. Like, okay, I want to go there, okay, I'll go there. I want to select between non-medical, medical, okay, I'll select non-medical. You have not given a thought in that, right? Okay, which college I will go? I will not give a thought, okay, this college I will go, right? That means you are very reactive in nature. So when you are very reactive, you are not selective. That means reactivity and selectivity are inversely proportional to each other. Reactivity and selectivity are inversely proportional to each other, isn't it? Reactivity and selectivity are inversely proportional to each other. If something is very reactive, it will be less selective, right? Okay, yes. Now, If something is very reactive, then it is very selective. Now, what will happen in this case? What will happen in this case? Right? That means the selectivity order will be. Now, I'll tell you why I'm teaching you all of these things. Right? These are your questions of JEE Advanced. Okay. So, selectivity will be Br2 is more selective as compared to Cl2. Br2 is more wise. He's like, I want to do this or that. I'll give a thought about it. I'll think about 2-3 days and I'll come to a decision. I'm not very reactive in nature. That is why when we talk about the reactivity, selectivity, Br2 already is like my 3 degrees more than 2 degree. Then I have 1 degree. Always this is going to be my stability order. I'll tell you why I'm telling you all of these things. Here it will be confused. It will depend. Sometimes though in hurry you can take the right decision. Sometimes you will take the wrong decision. But if you have given a thought to it, you will always take the right decision, isn't it? If you have given a thought to something, you will always take the right decision, right? But for example, you're not thinking, like just you are randomly guessing it, like, okay, maybe we'll see, like we'll see, right? So in that case, maybe the decision will come out to be right, or maybe the decision will come out to be wrong, right? So here, chlorine is confused, right? So that is why I'll tell you why these things are important. For example, you have a question. I'll just write down one question here. The question is, wait a minute. The question is, the question is this one. The question is CH3. This is CH3. This is CH3. And this is H. Now, this is the question that you have. Now, you have to think about this thing, right? That means what you want to select. See, two things can happen. We know that hydrogen is replaced, but ma'am, the question is which hydrogen will be replaced? You can have two answers here. Because this hydrogen, if this hydrogen is replaced, it will be CCl, CH3, 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 right? If this hydrogen is replaced, then it will be C, CH3, this is H, this is CH3, this is CH2Cl. Now the question is, what will be the right answer? Right? What will be the right answer? I'm just giving you X here, right? And this X can be bromine or chlorine. Now you need to tell me, in case of bromination, what will be the correct answer? In case of chlorination, which will be the major product? We need to identify the major product. That is why we need the use of reactivity and selectivity principle. That is why I was telling you about this reactivity and selectivity. Now everybody tell me, is this thing clear to everybody, that why I am using this thing here? Why I am using this thing here? Everybody in the chat box. Yes, everybody. Now I am going to tell you the probability factor. If you talk about chlorine, this is either 3 degree, for 2 degree, for 1 degree. What is the probability factor? I told you it is very reactive. That means it is very confused. Confused means these are very near to each other. Like you want to select a dress for yourself, right? You are not able to understand because you are like, okay, this is also good, this is also good, this is also good, that is also good. I don't know what to do. Chlorine is confused. Chlorine is confused, right? Now, if you talk about bromine, bromine is very wise, okay? It has clear-cut differentiation. This is 3 degree, this is 2 degree, this is 1 degree. You'll see the probability factor, the range of the probability factor is like really high. This is 82 and this is 1. Can you see? Here, the probability of forming 3 degrees 5, this is 3.8, this is 1, right? And this is 1600, 82, 1. Like, such a big difference here. Can you see how much confused chlorine is? Chlorine is not able to decide anything, right? So that is why for chlorine, we need to use one factor. We need to multiply this probability factor with the hydrogens, then we will see the more, which is the more number, which is the major number, that will be the major product, that will be the answer, right? So these are the two conditions. Firstly, I'll talk about chlorination. Firstly, I'll talk about chlorination here. If you do the chlorination, right? If you do the chlorination, right? If you do the chlorination, these are the two things that can be formed, right? If you do the chlorination, these are the two things that can be formed, right? Now I'll ask you that which is going to be the major product, but for that we need to do one more thing here, right? Now multiply the number of hydrogen with the chlorine, with the probability factor. This is Cl, this is also Cl. Two things can happen. Let us see the major product. See, this one is your, this one is your, this one is your hydrogen, that is 1 degree, because it is connected to one carbon which is further connected to only one carbon. So this is 1 degree hydrogen. This hydrogen is connected to that carbon which is further connected to which is further connected to 2 more carbons. So that will be 2 degree, right? This hydrogen is connected to that carbon which is further connected to 2 carbons. So it is also 2 degree. 2 degree. And this is also 2 degree. Right? This is also 2 degree. Isn't it? This is also 2 degree. Wait a minute. Wait a minute, this will be 3 degree, no? Wait a minute, let me draw it. Let me draw the full structure here. Okay, so let me draw it here. This will be CCH3. This is H, this is CH3. Firstly, we need to see which is 1 degree, which is 2 degree, which is 3 degree. This hydrogen is connected to that carbon which is further connected to 3 carbon. So this is your 3 degree, right? This hydrogen is connected to that carbon which is connected to 2 more carbons. So that is your 1 degree, right? Sorry, 2 degree, and this is also 2 degree. This is also 2 degree, right? This is also 2 degree, right? Okay. Okay. So now what you can see that for 2 degree, the probability factor is 3.8 multiplied by how many? 3, 4, 5, 6, 7, 8, 9. Right? But for 3 degree, the probability factor is 5, but we have only 1 hydrogen. So what is 9 into 3.8? What is 9 into 3.8? Let me see. 9 into 3.8, 9 is 27. It will be definitely more than this, right? It will be definitely more than this. 27 point something it will be, right? So basically 2 degrees more than 3 degree. 2 degrees more than 3 degree, right? So that means this will be the major product. 2 degree will be the, this will be the major and this will be the minor product, right? That will be the minor product. Okay guys? Yes everybody? Yes everybody? That is going to be the major product here. In case of chlorination we are talking about, right? In case of chlorination, right? Okay. Basically here what kind of product will be formed? You will have the halogen is connected to that carbon which is further connected to 3. So you are having the formation of 3 degree halogen as the minor one. Here the halogen is connected to that carbon which is only connected to 2. So 2 degree halogen is your major product. That is not usually. Usually we know that in free radical, if you talk about the stability of free radical, I don't know if you remember the stability of free radical also. Stability of free radical. Stability of free radical. So whatever is the intermediate, we need to see the stability of that intermediate. Generally, we know that if you have 3 degree, this is your 3 degree free radical, right? This is your 3 degree. This is 2 degree free radical. This is 2 degree free radical, right? And this is your 1 degree free radical. This is 1 degree free radical. We know that here we are getting inductive effect from 3 sides. That means the electron density is increasing here, right? Then you have electron density from 2 sides. Then you have electron density from 1 side. So when it is getting electron density, always consider free radical same as carbocation. Same as carbocation. Reason is, don't think that it has extra electron, ma'am. No, it is electron deficient only because its octet is not complete, right? So it is electron deficient, right? So free radical is electron deficient only. That is why when someone is poor, you are giving them electron, they are becoming more stable. That is why generally 3 degree is more stable than 2 degree than 1 degree. Bromine is very wise. It will not do anything. It will be always the answer will be always for bromine. The answer is going to be, if you talk about bromine, the answer is going to be 3 degree, then 2 degree, then 1 degree. Okay, if you talk about bromine here, this is bromine. This is bromine. If you talk about bromine, this is bromine. We know that this is 2 degree and this is 3 degree. Hence, this will be the major product in case of bromine. This is the minor product. This is, you don't even need to calculate anything for bromine. But for chlorine, you have to calculate. As you can see here, for chlorine, it was completely different, right? We had 2 degree as the major product, right? Okay. Yes, what is the doubt? What is the doubt? Everybody? Okay, guys. Shall I give you one more question regarding this? I think things will get more clear in your head. Right, I am giving you one more question, that is CH3, CH2, CH3. If you see that when you add bromine and sunlight, the answer will always be 3 degree, then 2 degree, then 1 degree. Right? So here 2 things can happen. Either the product can be CH2Cl, CH2CH3, or it can be this one, that is CH3CHCl, Now this hydrogen and this hydrogen are same only, so there is no third product that is formed here, right? Okay. Now see which is primary, which is secondary, right? So this halogen is connected to that carbon which is only connected to 1. So it is 1 degree. Here halogen is connected to that carbon which is further connected to 2 carbons. So it is 2 degree. That is why in the start I was telling you, understand what is 1 degree, 2 degree. Right? Okay. So now here bromine is very clear in life. He is like, okay, I have 3 degree, then 2 degree, then 1 degree. Right? So always it will be, this is going to be the major product. This is going to be the major product and this is going to be the minor product. For chlorine, I can't say. For chlorine, I'll have to calculate. Okay, so I'll calculate it for chlorine. So I'll calculate it for chlorine. What is the answer for chlorine? Let us see the answer for chlorine. As you can see here, this hydrogen is connected to that carbon which is further connected to only 1. So this hydrogen is 1 degree. This hydrogen is also 1 degree. But this hydrogen is connected to that carbon which is further connected to 2 carbon. The structure is like this: 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3. This hydrogen is connected to that carbon which is only connected to 1 carbon. But this hydrogen is connected to that carbon which is further connected to 2 carbons. So it is 2 degree, right? So it is 2 degree. So here you can write that this one is 2 degree, right? Okay. So what you can write here, if it is 2 degree, very simple thing. Still, how many 2 degree hydrogens we have? We have 2 degree hydrogen. How many 1 degree hydrogens we have? We have 6 1 degree hydrogens. We have 6 1 degree hydrogens, right? We have 6 1 degree hydrogens. What is the probability factor that I told you here? What is the probability factor, guys? What is the probability factor? 3 degrees 5, then 3.8, then 1, right? So what you need to do here? 1 degree is multiplied by 1, 2 degrees multiplied by 3.8. It will be 3 into 6. It will be more than 6. Okay, exactly. It will be, I think, 7.6. I think it should be 7.6. Let me see. 3.8 into 2. 7.6. Right. So 7.6 and here it is 6. So definitely 2 degrees more. 2 degrees more than 1 degree. Here it is. I told you that in chlorine, maybe the answer can be same as bromine. Maybe the answer will not be same. Maybe it can follow the same order or maybe it can follow the opposite order as well. It depends on the multiplication of number of hydrogen of that degree multiplied by the probability factor, right? So here 2 degree is the major. So you can say that here also if you talk about the chlorine, wait a minute, why I have written here chlorine? It should be bromine here also it should be bromine, right? Bromine, here also it should be bromine, right? Okay, here it should be chlorine and chlorine. So now this will be the minor, this will be the major in case of chlorine also, right? Okay, understood how to 2 degree will be major. Okay, are you able to, by mistake I have written it there, right? Okay, are you able to understand how to apply, how they can ask you question? And trust me, these kind of question can be asked in JEE Advanced as well, JEE Mains as well, right? Okay, yes, okay guys. So bromine is very clear in life, but chlorine is not clear in life. Chlorine is confused in life. Chlorine is all about, I don't know what to do, I am here, I am there, what is life is happening, ma'am. Like chlorine is very confused about life. Okay. Now, shall I start the next one, that is from alkanes? Everybody, shall I start the next one, that is from alkanes? What will happen? From alkenes, sorry, what will happen in alkenes? So, I'll give you firstly one very important thing which will help you in JEE Advanced questions as well, right? So, that is a chart, right? Very, very important chart, right? Why this chart? I'll tell you, because we will understand about syn addition, anti addition everywhere, and they will ask you the product, what kind of product can be formed, right? We know that there are two kind of alkenes. One is cis, one is anti. Sorry, one is cis, one is trans. Cis is if you have alkene and here you have Cl, here also you have Cl, here you have H, here you have H. That is trans. When two same things are opposite to each other, that is trans. What is cis? Cis means if you have a Cl here on the same side and HH on the same side, that is cis. Cis means sisters. Sisters are always with you, right? On the same side, they are not opposite you, right? So you can remember this by this thing, that cis sisters are always with us, right? So either alkene can be cis or it can be trans, isn't it? Either alkene can be cis or it can be trans. Now, like you, now other thing is alkene can be cis or trans, and there are two kind of additions, right? What are these two kind of additions? You have this alkene, right? We will also do this in hydrocarbons. We will do this like with more detail. We will do this in hydrocarbons because see, we are only left with one more chapter, that is hydrocarbons. So I decided to take up on next week, right? Hydrocarbons is a very big chapter, so I'll take it in 2 days, right? So now, if for example, one reagent from this side, other reagent from this side is attacking, that is an opposite attack. So it is anti-attack. If one reagent is attacking from this side, other is also attacking from the same side, that is a syn attack. Syn means same side, anti means opposite side. So there can be two type of attacks. One is syn, one is anti. So I'll just write it here. If cis is having syn attack, if cis is having anti attack. If trans is having syn attack, if trans is having anti attack. Right? Now you need to understand what kind of products will be formed here. right? What kind of products will be formed? A very important thing I am writing here. What kind of product will be formed here? See, same side is, if someone is on the same side as you will think they are positive. If someone is anti, opposite, trans, they will think this is a negative person, right? So here, sisters are beta positive, right? Trans, opposite, right? Sin, same side attack, positive, negative, same side attack, positive, this is negative. Till here, tell me, is there any problem till here, right? Chlorine is like you, chlorine is also beta like me, I am also like you. Bromine is too much sorted in life, okay? Now, we need to see what kind of products. This, so in the question, they will give you these kind of things, but the question that they are going to ask you, right? Let us see, that is based on the products, right? Always remember, multiply these two things. Positive multiplied by positive, the answer will be positive. No, answer will be positive. If you multiply two positive things, 3 into 2, 6. 6 is a positive integer, right? If you multiply one negative and positive, for example, minus 2 multiply by 3. This is negative, this is positive. Answer is negative. Answer is minus 6. So answer will be negative. You multiply one negative, one positive, again the answer will be negative. You multiply two negative. For example, you multiply minus 2 multiplied by minus 3. So answer will be plus 6, because minus minus will become positive. So answer will be positive. Ma'am, what is this positive negative you are telling, ma'am? See, positive again means same side. So we have two things. One is erythio and one is therio, right? One is erythio and the other thing is therio. Other thing is therio. So I'll tell you what is erythio, what is therio. Erythio is this thing. Erythio is this thing when you have same thing on same side. That is erythio. That is erythio. But when you have opposite, same thing on opposite side, like this. Now X and X are same, but they are on the opposite side. So this is called therio. This is called therio, right? So that is why we will say the answer will be erythio when we have positive. Erythio, erythio, this they can ask you. Here answer is therio, answer will be therio. Here answer will be therio. Here answer will be erythio. Okay, understood? Right? Okay. Okay. Sachin, no need for that, because I am going to take up live session, right? And I am going to teach you more advanced level of that as compared to NEET. So you don't need to go through that lecture, right? Okay. Now that is your erythio, that is your theory. I am also writing what is cis, what is trans here. This is H, H, this is X, X. This is H, H, this is X, X. So this is cis and this is trans, right? And what is sin and anti? Sin means same side attack, and anti means opposite side. Anti means opposite side attack, right? Okay, this is the question of your JEE Advance, right? Okay, so these things are important for to clear up your basics, right? Okay, I would have definitely scored if I had a lecture like you. Thank you so much, Hari. Thank you so much. Right? Understood this thing? Is this thing clear to everybody? Right? Just keep this as a very simple thing to understand, right? Usually it is taught in a very complex way, but actually it's very simple. Just remember multiplication. Multiplication, so you know what is, you also know what is anti-sin, you also know what is cis trans, you also know what is erythio theory. You just need to combine these things together, right? Okay, so now let's go to the reaction of alkenes. Okay, now let us see the reaction of alkenes here. So the first one is the addition. We need to see students what they feel. Ma'am, cramming the full mechanism is important. Yes, you should go through the full mechanism. You should understand the what is happening here, but take out the information from there. Now you need to focus on where you have sin attack, where you have anti attack, right? That you need to see from the reactions only, right? Okay. Now, yes. Now, addition of hydrogen halides. So, when you are adding HX here, right, is this a syn attack? Is this an anti-attack? From here, syn anti-attack questions are not asked. From here, Markovnikov, anti-Markovnikov kind of questions are asked, right? An alkene is converted to corresponding alkyl halide by reaction of hydrogen chloride, hydrogen bromide, and hydrogen iodide. So firstly, whenever this is happening, this bond will break, and to one pi bond you will have hydrogen, to other you will have X. But the thing is, if you have unsymmetrical alkenes, like you have C double bond C, CH3, here it is CH, here it is CH2. Now, ma'am, where should we have hydrogen, where should we have halogen? Ma'am, it will give rise to two products. Ma'am, which will be the major product here? So, it will follow anti-Markovnikov addition, right? So, it will follow Markovnikov addition, right? It will follow Markovnikov addition. That means less poor. That means if you have a negative anion, that means the negative thing will go to the less number of hydrogen, less hydrogen. So negative means rich. Here you can just remember rich and poor, rich and poor. So in a Markovnikov world, Markovnikov is a very good world, right? So here everything is right, okay? So in this world, rich should always go to poor, donate the money to the poor. So this is happening in a good world. Anti-Markovnikov is a bad word, right? So here opposite will happen. But in Markovnikov rule, everything good is happening. Rich is going to the poor one, which is having more electron density, that is going to the less number of hydrogen. So if you want to break this bond, like for example, you have this thing, here you have one hydrogen, here you have no hydrogens. So in this case, this is negative, this is positive, this negative will go to the less number of hydrogen. So that means halogen is attached here and hydrogen is attached here, and this is the thing that you will get, right? Rich to the poor, right? That is Markovnikov addition, right? That is called Markovnikov addition. Now the next one is, which is more reactive, HI, HBr, HCl and HF. See, down the group what will happen, the halogen, the size of halogen will increase, bond length will increase. So it is easy to break the bond of hydrogen and iodide, because iodide size is very large. So it is very easy to break that bond. Hence it is highly reactive. So hence the reactivity order is, this one is the reactivity order. Okay. Next is, here you have the mechanism. From the mechanism, what you need to see is the formation of this carbocation, right? And wherever in your life you see the carbocation, there will be rearrangement. There will be rearrangement of carbocation, Okay, there will always be rearrangement of, they are also known as, yes, mesorite. Yes, definitely. Right, I'll show you a question based on that, right? Okay, so whenever in any mechanism you see carbocation formation, always there is rearrangement possible. Now, if you're confused about rearrangement, I'm going to discuss that in GOC, right? I'm going to take one marathon of GOC, having all the effects, right? And carbocation rearrangement, hydride shift, methyl shift, right? It is needed everywhere. If you are targeting JEE means, JEE advanced, you don't know rearrangement, sorry, you're not on the right track, right? So I hope so all of you have an idea what is rearrangement. If you don't have an idea, don't worry, I'll get the idea for you, right? Okay, so this is the rearrangement is possible. Sometimes we don't directly apply this rule, instead we rearrange that, right? Rearrangement means we need more stable carbocation. If we have 2 degree carbocation, I'll rearrange it to 3 degree carbocation. That is basically called rearrangement, right? Okay, so here what is going to happen? HX will ionize, it will give us H positive, X negative, right? After this, you have this pi, you have this sigma. We know that pi electrons, they are having electron density, it is delocalized here, right? So that is why it will attack here, right? So what will happen here? this pi bond will break and to one position you will have the carbocation formation, then X negative will attack on the carbocation and hence you will have the formation of the corresponding alkyl halide. Okay, you will have the formation of corresponding alkyl halide. Now, here they are giving you that the negative part will go to this and this Markovnikov rule they are telling you. The modern version, this is very important, very important. This is the rearrangement they are telling, right? In this they are telling you the rearrangement. I will give you one question based on this. Rearrangement. They are saying that earlier we used to think that there should be Markovnikov addition easily. But now in JEE means they will not ask you easy questions. They will not ask you calculate less number of hydrogen then give the answer. Right? You are not in 9th and 10th class. This is not a question of board exams. Right? So they will ask you rearrangement based questions. Right? So that means the modern version is that firstly you will have the rearrangement of the carbocation which will lead to the 1,2 hydride or 1,2 methyl shift. You're like, ma'am, I am not able to understand what you are saying. So I'll tell you how to understand this thing. Okay, I'll just let me see if I have any example here already written. Right, let me see. I should have one example here already. Right, but I need to see that. Alcohols, then you have not preparation. Just give me a second. Okay, so let's do one question here, right? One question. Okay, we don't have that kind of reaction. I'll have to make it myself, right? I don't have that kind of example. Let me see. Okay, C double bond. This is CH3. Then you have CH2. CH, C, CH3, CH3, CH3. Now this is your answer. This is having C, one hydrogen here. Let's take 1, 2, 3, 1, 2, 3. Let's take one hydrogen here. Now, let us solve this. Okay, let us solve this question. Okay, let us solve this question. Here you have which thing? You need to understand the rearrangement of carbocation here. Right, directly telling you the reaction is like this, so you can see in also books, right? So directly what to tell, right? You need to see how to solve the questions. Now, for example, they are telling you this is HCl, and directly if you have HCl, that means you are applying Markovnikov rule here. Markovnikov rule means this Cl negative will go to less number of hydrogens. So it will form this kind of carbocation CCH3. This is CH3. This is CH3. And this less, the carbocation will be on the less number of hydrogen position. So here you have CH, here you have CH2, right? So here in case of CH2, one hydrogen will be added and here you will have the formation of carbocation according to Markovnikov rule, right? So that carbocation will be formed to that carbon which has less number of hydrogen. This is the Markovnikov rule, right? After this, what students will do, they will directly add Cl and they will say, this is my answer, ma'am. This is my answer. I'll say this is the incorrect answer. Why? What is the reason behind that? Let us see. What is the reason behind that? Let us see. So this is your carbocation. Now this carbocation, right? This carbocation is 1 degree or 2 degree. This carbocation is connected to how many? This is connected to how many carbons? This is connected to 2 carbons here, right? This is connected to 2 carbons here. So what can I say? This is my which kind of carbocation? This is my 1 degree, or you can even take this example. You can even take this example. If you even take only 2 methyl groups also, then you can solve this. I'll also tell you how to solve this for 3 methyl groups. Firstly, let us see how to solve it for 2 methyl groups. right? Otherwise that will be too much for you. Now here this carbocation is 1 degree or 2 degree. This carbocation is a 2 degree carbocation because it is connected to 2 carbons, right? Okay. Now what we'll do, this hydride is shifted here and hence you will have the rearrangement. This carbon, this CH3 and this CH3, hydride shift is happening from 1 to 2 position. So here you will have the carbocation and one hydride is shifted here. Here we will have the CH2 and here you will have CH3, and after that you will add the halogen here. Now you are going to add Cl negative and hence you will have the answer as CH3, CCH3, and this is Cl, then you will have C H2 CH3. This will be the correct answer, right? Okay, this is what I wanted to tell you when I was telling you about the rearrangement. Okay, understood guys? Everybody guys, please don't spam, right? Please don't spam. Okay, so this is what I was telling you when I was telling you about the rearrangement here. Is that clear to everybody here? Is that clear to everybody here or not? Is that clear? Everybody in the chat box. Everybody in the chat box, is this thing clear or not? Is this thing clear or not? Do you want one more question on this? Do you want one more question on this? For example, you don't have rearrangement like this, but you have a question. Okay, let's take an example. You have a question where you have one CH3 group here, right? You have one CH3 group here. Again, the carbocation that will be formed is to less number of hydrogen only. So one is CH3, other is CH3. There you have CH3, and here you have CH positive, and this is single bond CH3. Now there will be not hydride shift, there will be methyl shift. Because what is this carbocation? This is carbocation is connected to 2 more carbons, so it is 2 degree carbocation. Now what I want to do, I need to rearrange this to make more stable carbocation. If to this carbon I have the positive charge, then I can make it 3 degree carbocation, and always 3 degree is more than 2 degree, then 1 degree is more stable. So what I will do here, I will rearrange this. I will rearrange this, right, to 3 degree by doing the methyl shift. This methyl will be shifted here and hence it will change, right? These kind of questions guys you should do, right? If you really want to score good marks in your JEE, right? Then this is CH3. This methyl is shifted here, and to this carbon you have the carbocation, right? To this carbon you have the carbocation, right? Tell me guys, is this thing clear? Now I am adding the halogen, whatever halogen, Cl negative. So this is CH3, this is C, this is Cl, this is CH, CH3. And you know what? In the options you will also see where halogen is applied here, right? So that's why I am telling that these kind of questions are simple, easy to score, right? And good questions, okay? Okay, yes everybody. Zone Gaming Tamil, don't do spamming here, otherwise I'll have to block you. I don't want to do that, right? Okay, don't spam. Let me complete at least one topic, then after obviously I'll give you break, right? You guys are the only sitting, I'm to standing there, right? So just relax. Understood this thing? Everybody in the chat box, are you able to understand this thing? Now rearrangement is not only for 1 degree, 2 degree, 3 degree. There also can be one more kind of rearrangement. They can also ask you that, one more thing, that if you have one phenyl group here, then what can happen? Right. I don't want you to get confidence just by seeing the reactions. I want you to understand the concept, do the questions. Maybe it will take us maybe today or maybe tomorrow, maybe I'll take one class, extra class also. But I want you guys to actually understand what is happening here, right? Okay, to understand the core concepts here, right? Okay, now what we are going to do here, firstly, according to Markovnikov rule, just add H positive, right? So make this benzene, to this is CH2, this is CH, to this you have positive, to this you have CH2, right? Now, I know that which is more stable. You'll be like, ma'am, how does it matter, ma'am? How does it matter, ma'am? Why it doesn't matter? Because you won't be able to identify that which is 1 degree, which is 2 degree. You see, ma'am, this is also 2 degree. If I make positive here, then also it is connected to 2 carbons only. Ma'am, both are 2 degree, ma'am. Then why we need to rearrange it? Because guys, this phenyl carbocation, it has resonance, and whenever there is resonance, it is more stabilized, right? It is extra stability is there. And whenever, very good. So whenever there is stability, phenyl shift, no, phenyl shift will not happen. Whenever you have resonance, that means this carbocation is going to be more stable. Now the another question that I can see from Nihar, because he is trying to understand, right? So I'll tell him that always remember, you should stay happy in life, right? So always remember happy me. What you need to remember? Happy me. So this is the migratory order. This is a migratory order because now you have a choice. If you have hydrogen, you will select hydrogen only. Hydrogen has maximum migratory aptitude, he wants to go. Then phenyl has next migratory aptitude, then least is for methyl, right? Okay, so here hydrogen will shift. There will be hydride shift only, right? There will be hydride shift only. This is carbon. This is carbon. Let me write it here. This is carbon. It is positive. It is connected to one hydrogen, one phenyl here, right? Then one CH, hydride is shifted here. It is CH2, it is CH. Here it should be 3. It is CH3. Then you add the Cl negative here. You will get phenyl, and to this you will have CH. Here you will have Cl. Then you will have CH2, CH3. This will be the product. This will be the product. Understood? Yes, everybody, understood or not? Okay. Always this is the migratory aptitude, right? So you don't need to get confused. This is very rare that they will confuse you between the shifts here, right? But still, if they confuse you, then this is the migratory aptitude. Okay, everybody in the chat box, right? Which includes phenyl shift. Phenyl shift can happen in case of, if you want to see that case here you can have the phenyl shift. Let me draw it here. Okay. If you want to see a case where very rare chances that they will give you question based on phenyl shift. But if you want to see that, ma'am, how phenyl shift will occur. So guys, I'm just, instead of this CH3, I'm making pH here, right? I'm making pH here. This is pH only. pH means phenyl, right? So now, here what I can do, let's make 2 phenyl here. That will give like more probability of phenyl shift, right? Now, I don't have hydrogen. If you don't have hydrogen, you have a choice between phenyl and methyl. So phenyl will have more shifting. So that is the reason what we are going to do here, this is not applicable only in this case. Okay, this is wherever in this whole organic chemistry, you see that, ma'am, there is formation of a carbocation. You need to make these arrangement here. You need to do the rearrangement. I'm sure about that. If they ask you these kind of question in JEE Advanced, definitely there will be rearrangement. In JEE means also there will be chances of like rearrangement. That much easy question they will not ask you, right? Okay, so here what you need to do, definitely we have the option of phenyl shifting. So phenyl shift will happen here, and the answer will be C positive. This is CH3, this is PH, this is PH, this is C, and this is also PH, this is H, then this is CH3. Then after this, what will be formed? Cl will be added here. This is CH3, CCl, CH3, this is PH, and here it is CH, PH, and this is CH3. Okay. Are you finding this difficult now? Are you finding this difficult now? Right? If you see the direct question, then you will find that, ma'am, I don't know how this is happening. Right? Okay, but I think now it has become really easy for you to understand which rearrangement will happen. Okay? Understood? Everybody in the chat box? So that was about Markovnikov rule. So it's not only less number, you also need to understand where you have which kind of shifting, rearrangement, right? That also is important whenever you see carbocation, right? Now next thing is the anti-Markovnikov rule. Now for anti-Markovnikov rule, as I told you, in case of free radical mechanism, you need to have either heat or electricity or light or peroxide. And here we have added peroxide, right? So here we have added this peroxide. That is why this occurs by free radical mechanism, right? This occurs by free radical mechanism. This occurs by free radical mechanism. Now let us see the mechanism here. If you want to see the mechanism, let us see the mechanism also. See what will happen here. What will happen here? From peroxide or no peroxide, if you add the peroxide, right, then what will happen? And this is only in case of HBr. I am writing it here. Only for HBr. This is important to note down. For Cl, there is no change. Whether you add peroxide, you don't add peroxide, answer will be according to Markovnikov and carbocation rearrangement only. But if in case of HBr, you have added peroxide, then the answer will be opposite, right? So with peroxide, what will happen? More number. Now in anti-word, so you know that in anti-word, what will happen? Rich will go to rich. Now we know that we are living in Kalyug. This is the anti-word. It's not like rich person will go and donate to poor. No, this doesn't happen, right? Rich will only go to rich. Ambani doesn't come to us and donate us, right? Okay. So here rich will go to rich. Negative will go to more number of hydrogen. More hydrogens. Okay. Negative will go to more number of hydrogens. So here you don't need to know carbocation, no rearrangement. No rearrangement. I'll just write it here. Wait a minute. Okay, I think here only I should write negative 2 more hydrogen, no carbocation because it is a free radical mechanism. So no rearrangement, no rearrangement, no rearrangement, no rearrangement, right? Okay, and this is not applicable for HCl, HBr. So if you have peroxide here, it will go to more number, so Br will be added here, right? If you have no peroxide, so Br will be added here. But if you talk about peroxide, this is HBr, this is also HBr. If you talk about HCl, whether it's peroxide or no peroxide, answer will be same. Answer will be CH3, CH, Cl, CH3. This will be the answer for HCl, whether you have added peroxide or you have not added peroxide, right? Ma'am, if methyl is shifted in case of, then positive charge will be in one carbon, so more resonating structure with two phenyl groups, so more stable cation. No, ma'am. This is actually the migratory aptitude, right? That is observed for rearrangement. That firstly you have hydrogen, then you have phenyl, right? This is then you have methyl, right? This is the migratory aptitude that is observed, right? According to that migratory aptitude only I am giving you the answer, right? Okay, that is not based on the stabilities, that is based on which is more good in migrating from one side to the other side, right? Okay. Okay, lol. Your names are really interesting. Lol, funny. Ma'am, why is anti-Markovnikov rule when a peroxide is added? Because of the, because it's actually based on the mechanism. Because of the free radical, no, what will happen? A free radical will be formed, right? When a free radical is formed in that transition, it will have, okay, I'll give you just one hint here. What will happen in that transition? Peroxide will be linked here. Peroxide is linked here. That is why there will be no space for Br to attack. That is why Br will attack here only. Right? Br will not be able to attack there because of it will have no space in the mechanism. Right? It is there in the mechanism. I think mechanism we will do that in hydrocarbons, right? In detail. Right? Because in hydrocarbons we discuss about this alkanes, alkenes, alkynes. Right? Okay. Now, next is from alkenes. Second part is addition of X2. So, if you're adding X2 here, first thing is what kind of thing is formed? It is a halogen, chlorine, bromine only add at ordinary temperature. Ordinary temperature. That means it is not a free radical mechanism, right? To alkenes in presence of inert solvent, for example, CCl4, to produce vicinal. Do you know what is vicinal, what is geminal? Gem. So I have like tricks, simple things for everything. Gem, when we say this is gem of a person, if someone is loyal to one person, you will say that is gem of a person, right? So gem means geminal. Geminal means only loyal to one person. So that means to one carbon, if you have two halides, that is geminal. Halides or alcohol maybe, that is called geminal. If to two adjacent carbons you have two halides, that is called vicinal. That is called vicinal. So here geminal is not formed, rather vicinal is formed. Let us see how vicinal is formed here, right? Let us see how vicinal is formed here. Here the important thing is that it is having a anti-attack here. Right, how it is, you don't need to get into the mechanism again. Just remember the important point here, that here firstly Br2 will attack, right? You will have a formation of cyclic halonium ion kind of thing. Cyclic intermediate will be formed here. That is why the another Br negative will attack on the back side. That is why anti-attack will happen. Right, that is why there will be anti. Just remember, in Br2 at normal conditions you will have anti-attack because of the cyclic intermediate that is formed here. It will have no space, right, but it should have, like, you know, it should have back attack only. It has only one choice, right? It can't attack from this side. It can only attack from this side or from this side. Right, it cannot attack from this side or this side. Same attack is not possible in this case. That is why anti-attack, and this is anti-stereochemistry. That is why Br is here, anti-stereochemistry, opposite, in the opposite side Br is attached. Right, okay. Now, if you talk about Br2, we know that it is having reddish brown color. Right, when you have unsaturated compound, this is basically the test for unsaturation also, in presence of CCl4, what will happen? You will have colorless vicinal halide will be formed, and this is called the test for unsaturation. Test for unsaturation. You will test here whether we will have the presence of unsaturation, whether any double bond or triple bond is formed here or not. For triple bond, the reactions are there in the hydrocarbons, that how it reacts with triple bond, right? Okay, so but with double bond, it will form vicinal dihalides, and this is called test for unsaturation, where the reddish brown vapors of Br2 is vanished and you will have colorless compound formation. Reaction for fluorine is explosive, where iodine reacts very slowly. That is why we don't take these two reactions here. Right, always just remember, fluorine is very explosive, iodine is very slow and reversible process, right? So we won't be able to make the products, right? Now, just by this thing, I want to show you that what we did previously. For example, you have a cis compound, this is CH3, very important reaction, very important question, right? This is CH3, this is CH3. I am saying that you are adding Br2 in presence of CCl4. This will be given to you in the question, okay? And here they will ask you, you have a trans compound CH3, this is CH3, this is H and this is H. And this trans compound also you are giving the reaction of Br2 in presence of CCl4. First step a student should know, that is it is a anti compound. It is an anti-stereochemistry is happening here, right? Anti thing is happening here. Now, if you know that this is anti, then understand one thing, that this is positive, this is cis, so it is positive. Anti means a negative. Anti means a negative. This is trans, that means it is negative. Now understand one thing, guys, with positive and negative you will get therio compound. So what kind of compound you will get? A therio compound, that means you have CH3 here, you have CH3 here. Therio means opposite side. So you will have Br on the opposite side, right? This is your JEE advanced question, okay? So here you have CH3, here you have CH3. But when you add two negatives, you will get a positive, right? When you add two negatives, when you multiply two negatives, you will get a positive, right? So here that means erythro product is formed. That means Br2 is added on the same side, right? Br2 is added on the same side. So this is your erythro. This is on the opposite side. No, this is therio, and this is erythro. This is erythro. Okay, this is erythro, right? Okay. Same side is geminal, no ma'am. Both present on same side is geminal, no ma'am. Yes, same side I have written here, na? Huh. Yes, same side, geminal, right? Okay, vicinal means on adjacent, not same side, on same carbon, right? Side we don't know, on same carbon, that is geminal. On two different adjacent carbons, that is your vicinal. Okay, understood? Understood, guys? Now, these kind of question can be asked. Very, very important. Right? What kind of product will be formed here? Okay, guys? Yes, everybody. Now, what do you think? We should take a break or we should continue? I think we should take a break now. Right? Okay? I think we should take a break. But we can easily complete like... we can complete the mechanisms. We can complete the preparation here, okay? We can complete the preparation if you want me to complete. Or do you want to take a break? Because I can see the live watching is dropping. Students, I think they want break now. Is it? Do you guys want break? Hanji, do you guys want break? Do you guys want break? After break question. What if the questions are based on these kind of concepts? Then I have to tell you the concept also, no? So otherwise it will be a mess, right? Otherwise it will be a very big mess. Don't worry, I'll take up the questions also, right? Okay? Okay, guys. So I think it's time for the break. Let's take break, and after the break, I'll teach you the other preparation and also the properties, right? Okay? Chalo. So let's take break now. So I'll see you at 8:20, right? At 8:20 I'll see you guys, right? So class will resume at 8:20, okay? Resume at 8:20 p.m. You can have your dinner, and after that I'll see you all. Hi everyone, welcome back after the break. So I hope so you had your dinner. So I also had my dinner. And let us now resume the class. Everybody in the chat box, let us resume this class. Okay, everyone here, everyone. So let us resume this class and where we were, yes, addition of hypohalous acid. Okay, guys, I'm going to restart now, right? That means I'm going to resume the class now, right? I'm not going to repeat what we have done before, right? Okay, so I hope so you all are here present. And yes, what have you eaten? I have eaten chapati with nutri, protein rich food I try to eat, right? So I have eaten chapati with nutri, a mix of good proteins and carbohydrates and fats also with some desi ghee, right? Okay, same here. Hi-fi Radha. Even I had my dinner in a very manner. My mom was like, oh my god, she's in such a fast manner she's eating. Otherwise, I'm very slow eater. But now, because of the class, I was eating very fast. Yes, because yes, the lecture is important, no? Okay, so here the addition of hypohalous acid, that is HOX to the alkene. So you have this as your alkene and you are adding X2 here, right, with water. Now this will form a hypohalous acid, that is HOX, right. Now from this HOX you will have OH negative and X positive here, right. Wait a minute, that is oxygen and halogen. Halogen is more electronegative, that depends. So here you will have OH negative and this is the positive, right? And this is how they are going to attack, right? So your negative part, that is OH negative, to less number of hydrogens, because here you have less number of hydrogens. So it will attack on this carbon, and positive part on more number of hydrogens, and hence you will get the formation of vicinal halohydrin. That means on two positions you have halo and on one position you have hydrin. So vicinal halohydrin is formed here. Alkenes form halohydrins with hypohalous acid, right? Order of reactivity again, it is HOCl, then you have HOBr, then you have HOI, right? The reason is oxygen and halogen, the electronegativity difference here. We know that down the group electronegativity will decrease, right? Hence your electronegativity difference will be less. Hence it is difficult to break the bond of oxygen and halogen here, right? So that is why the reactivity order of chlorine is more as compared to iodine. But when we talked about simple halogenation, in that case F2 was having maximum reactivity, then Cl2, then Br2, then you had I2, right? Okay, then we talked about HBr, HX. So in that case the maximum reactivity was HI, then you had HBr, no, HBr, yes, then you had HCl, then you had HF. That was the reactivity in halogen halide. But in hypohalous acid, the reactivity is based on the electronegativity of oxygen and halogen bond that we need to break here. That is why this is the order of reactivity, right? Okay. Yes. Now let us see the mechanism here. As you can see the mechanism, guys. So this is Cl positive and negative, right? So basically this is a polar molecule only, right? There is no polarity difference here. But what will happen, because of this pi bond, there will be generation of this polarity. And in the slowest step, you will have the formation of a carbocation, right? You will have the formation of a carbocation, and after this carbocation formation, then you will have the fast reaction where in this water, this O lone pair of this oxygen are going to attack on the carbocation, that is this one. It is going to attack here, and hence you will have the formation of OHH, and now H positive will leave from this side and electrons will be donated here in the next step, and hence you will have the formation of this H positive will leave, electrons will be shifted here, and hence you will have the formation of halohydrin. That is, here we have chlorine, so it is chlorohydrin that will be formed, right? Okay, okay, okay guys, it's not always reaction happen in unidirectional method. Some reactions are also reversible, that are bidirectional also, two directional also, backwards also they can happen. Not all reactions are unidirectional, okay? Now, next is alicyclic or alpha halogenation, again a very important reaction. Here we are saying that allylic alpha, for example, this is your allylic molecule. In this case, how you are going to form the product, right? So, chlorine or bromine replace hydrogen and the alpha carbon atom with respect to double bond, that is the allylic condition, at about 500 degree without breaking the double bond, right? For example, you have this compound. Now, this is very, very important thing, that in this what will happen? What is the allylic position? Here we are saying the temperature is 500 degrees Celsius. 500. See, temperature, how much it matters to us. When the temperature in case of alkanes was 500 degrees Celsius, there was substitution reaction. We did chlorination, bromination, reactivity, selectivity principle. But in this case, we have alkenes. In this case, what will happen? Again, the hydrogen will be replaced, but this will be the alpha carbon of the double bond. That means the allylic position. To this double bond, the alpha carbon is this one, and this hydrogen will be replaced here. So, it will be CH2Cl, CH double bond, CH2. Double bond will not be affected here, right? So, allyl chloride is formed here. Similarly, here this is the alpha carbon. So, to this hydrogen will be replaced and you will have CH3, CHCl, CH double bond, CH2. Substitution proceeds by free radical mechanism here also. So, basically when you are having Cl2, Br2 at a very low temperature, there is no free radical mechanism. At high temperature, there is free radical mechanism. Substitution will happen here, right? So, when you have high temperature and Cl2 or Br2, in case of alkane, we know the process of reactivity, selectivity. In case of alkene, you should know that allylic position will be substituted, right? Okay, yes, okay. Now, next is this thing. For example, this is the compound. Now, this is a very important thing. Either you should have Cl2, Br2 at a very high temperature, or this is also applicable in case of alkane, right? Also, when we did that reactivity selectivity principle, when CH4 was converted to CH3Cl, in that case also, if you don't want to use Cl2, Br2, high temperature or sunlight, you can also use NBS there. You can also use NBS, that is N-bromosuccinimide. Very, very important thing, N-bromosuccinimide. So, what will happen in case of N-bromosuccinimide? So, this bromine will be released in case of N-bromosuccinimide and it will attack here at the allylic position only, right? And succinimide will have the attachment of hydrogen from here and you will have the formation of succinimide only, not N-bromosuccinimide. That means on the N position, on this nitrogen, you had the Br that will be taken away by the allylic position and the hydrogen here will attack here and you will have the formation of succinimide, right? NBS it is called. Again, a very important reaction. Okay, 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 very good. Now, next is this, so they are telling you that thing only, ki NBS what will happen, right? So, they will form NH and Br2 will be released and after this Br2 will behave in the same way as Br2 at high temperature behaves, right? So, NBS provides a constant low concentration of Br2. This is catalyzed by HBr, trace amount of which are usually present in NBS, right? Okay, Next, very important. Again, this was also your JEE advanced question only, right? Okay, this was also your NEET NEET, I'm saying JEE 2024 JEE advanced question. Okay, 2024 advanced question. Now, let us see what we are talking about here. We are saying that when you have alternate double bonds, right? You have alternate double bond, single bond, double bond. Because of the conjugation, we know that double bond will be shifted here, it will be shifted here. That means these pi electrons are delocalized all over here, right? That is the reason what will happen. We will think that in adding Br2, maybe on this position Br will be attached, maybe on this position, but actually the answer will be quite different for what we expect. So what will happen here? There are two products that are formed. Minor product is you are thinking that this pi bond will break, and two less number here you will have Br addition, here you will have Br addition, right? This is the minor product. Now what will happen here, that, wait a minute, yes, what will happen that this is your alternate double bond single bond molecule. Now conjugation will take place here. That means what will happen here in this case, when Br positive will attack here, two things can happen. Either it can attack on this pi bond here or here, and you will have the formation of this thing, right? If it attacks on this particular pi bond, then Br will be attached here and here. Other thing what can happen is that this pi bond is shifted here, okay? I think they have not shown it here properly. So I'll show you that what exactly can happen here. You have CH2 double bond CH, single bond CH double bond CH2. So what can happen that this pi bond can shift here and this electron can shift here, and hence you can have the formation of CH2 negative C double bond CH double bond CH. This is CH2 positive, right? And to these two positions Br2 can be attached, and hence you can have the answer as CH2. This is Br and this is also Br, because Br2 is Br positive and Br negative. So Br positive can attack here, Br negative can attack here, and hence you can have the formation of 1,4-bromo, right? 1,4-bromo, right? So this is what we are saying, that you can either have this thing, right? That means either this thing can be formed or this thing can be formed, right? Okay, so if this double bond, right, this so I am showing you in a simpler way. This so I showed you in a simpler way that due to conjugation this is happening. But in reality, we have the formation of a carbocation that looks like this. This pi bond will break, right, and one Br positive will be attached there, and you will have the formation of one carbocation here, right? So Br positive, because it is following Markovnikov addition always, right? If nothing is mentioned, that means Markovnikov addition is applied. So that means the positive will be attached to more number of hydrogen. So here Br will attach here, and here you will have the positive. So this is the compound that is formed. Now there will be conjugation that will happen, double bond, single bond, carbocation, right? So that means pi bond will shift here and the carbocation will shift here, and hence if you add Br negative here, it will be Br here. If you add Br negative here, it will be Br here, and hence two products can be formed here, and the major product being this one. This one is your major product, that is called 1,4 addition, right? So that is called your 1,4 addition, right? 1,4 addition product is formed here as major, right? Okay, 1,4 addition product is formed as the major product here. 1,4 addition, that is the major product. Now very important thing here to note down, that if you have low temperature, right, if they have given you low temperature, then major product will be your 1,2 addition product. This is 1,2 addition, right? Okay, here it should be Br only. Okay, wait a minute. This they have not shown here, na? Have they shown here? No, they have not shown it here. Huh. Chalo, I'll just write it here only, right? So this product will be formed as the major product. I'll just write here. This is 1,2 addition product. This is 1,2 addition product. And this is your 1,4 addition product. So 1,2 addition is the minor, 1,4 is the major addition product in case of when you are adding Br2 here, right? But when you are adding halogen acid, that means HX you are adding. In that case, you can have both as major and minor product depending upon the temperature. Same thing can happen. Either to less number you should have added Br and to more number H should be added. So either this product is formed, right? Break this pi bond and you have H formation here. You have H here and Br here according to Markovnikov. Or what else you can have? This is CH2. This is H is added here. So it will be CH3. This is CH positive. This is CH double bond CH2. Now again what can happen? This pi bond can shift here and hence you can have the formation of CH3, CH double bond CH, CH2 positive, and hence from here you can have the formation of this product where Br negative is added here and hence Br is added to this place, right? Hence you can have the formation of this product from here and this product from here. If Br is added to this position, then you have the formation of this product. If Br is added to this position, you have the formation of this product. Here, you know that you are adding 1,2 position. On the first and second position, you are adding H and Br. So, it is 1,2 addition product. Here on first and fourth position, you are adding H and Br. That is why it is 1,4 addition product. Now 1,2 addition product is preferred at low temperature, but 1,4 addition product is preferred at high temperature. Okay, 1,4 addition product is preferred at high temperature. Okay guys, yes everybody. Now next is the mechanism here. As you can see the mechanism, it is carbocation formation only. Right, pi bond will break, you will have the formation of this carbocation. Then as I told you, conjugation will happen and you can have the formation of this carbocation after this. Right, this carbocation can be formed. If you have this carbocation, then 1,2 addition product, and if you have this carbocation, 1,4 addition product is formed. Preferred at low temperature, preferred at high temperature. Right, okay, yes everybody. But this is important for whether you are preparing for JEE, NEET, this is important for you, right? This is a very important chapter, right? Okay. Now, next is addition of halogen to alkyne, that is triple bond. So, if you have triple bond, what can happen when you add halogen here, right? So, same thing will happen, very, very important. Firstly, we know that anti-addition, this is the anti-addition. So what will happen? Pi bond will break and Cl will be attached to the anti position. So what you will have the formation of trans product is formed. You are adding more CCl2, Cl2 in presence of CCl4. Or you are adding this and that. What can happen? Again this pi bond will break and you can have the addition of more chlorine here and hence this will be formed here. That means overall both the pi bonds will break and you will have the formation of, instead of that pi bond, 2 Cl atoms will be attached to it on the vicinal positions. Right? Okay. So, what you will have? 1,1,2,2 tetrachloroethane will be formed. What you need to remember in the first step, this is the anti-addition step. Right? Here also anti-addition step is there. Okay. This is also anti-addition. Okay, both are anti-addition only. Whenever you have on the pi bond, there is Br2CCl4, Cl2CCl4, that means you are doing anti-addition here. Right? Okay. Now, next is halogen exchange reactions. If you talk about halogen exchange reactions, you already have alkyl halide, you want to form another alkyl halide. I told you that fluorine, it is difficult to react, iodine also it is difficult to react. Fluorine because it is very explosive in nature, iodine because it is very slow and reversible reaction. We won't be able to make Ri, but the reaction will keep going backwards and backwards and backwards. That is why what we will do, we will use halogen exchanged product here, right? So what we will have, we have Rx plus Na. It's a very simple way to understand. There was a guy named Finn, okay? Finn was like, I want to, this is Roxa, this is your girl Roxa, and this is Finn. Finn is like, hey Roxa, why don't you do some fashion? Why don't you apply some nail paint on your hand? Nail paint, we know that in nail paint we have acetone, right? So Finn is always saying, why don't you apply fashion? Why don't you apply some nail paint on your nails? Roxa is always saying, no, 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 nahi, 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 I don't want to do this, nahi, 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 no, 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 right? So Roxa is always saying no to Finn, right? So NaI, dry acetone, and after this just do the displacement and it will be Ri and NaX, right? So here NaCl, NaBr is precipitated in dry acetone, facilitates the forward reaction according to Lee-Chartler principle. Now what do you mean by this thing? They are saying this NaX formed is dissolved in the dry acetone. So according to Lee-Chartler principle that we have studied in equilibrium, if you want to increase the product side, if the product is consumed, Lee-Chartler always like, reaction will always go opposite to what you do. You're like, don't go there. Reaction will be like, I will definitely go there. You say, don't wear that. Okay, you are stopping. I'll definitely do this. It's like a stubborn kid, right? So it's like my parents will know to what thing, I'll do that thing only, right? So here Lee-Chartler is like that. Right, so Lee-Chartler principle said that if you decrease the concentration of product, it will try to increase the concentration of product because it wants to go opposite to what you do. That is why the reaction will be facilitated in the forward side according to Lee-Chartler's principle, right? It proceeds through SN2 mechanism and the nucleophile is I negative. Right, now this is important. What is SN2? Right, I'll tell you what is SN2. Just mark this thing here that it follows SN2 mechanism. 2-1-1-2. Just remember 2-1-1-2. 2-1-1-2. 1-2-1-2, 2-1. Right? So 2 means it is a bimolecular and one-step reaction. And I'll just tell you, we will do that in detail also. One step means it follows transition state. There is no carbocation formation. No carbocation. No carbocation is formed here, right? No carbocation is formed here. It is a transition state. I'll tell you in detail what is this SN2 mechanism, right? Then you have Swartz reaction. Then again you have this Roxa. This is, let's say, Rx. Roxa, again you have Roxa. Now Swati is Roxa's best friend. Swati say, hey, why don't you do some fashion? Fashion means fluorine. Now Roxa will agree to Swati because girls will always agree to whatever their best friend will say, right? So she will agree to Roxa. She will be like, yes, okay, Swati is telling me to do fashion, I will do fashion. Fashion with a silver ring. Like that means inorganic fluorides will be used here. Cobalt fluoride, silver fluoride, mercury fluoride, you have, right? Bismuth fluoride, okay, different fluorides will be used here. Again, this is a SN2 mechanism. And nucleophile is F negative, right? Again, it is a SN2 mechanism only, right? Next, from carbonyl, you have a ketone or a aldehyde. What we can do? Add PCl5 here. Instead of this double bond O, you will have 2 ClCl here. This is what you will get, right? Break the double bond O, you will get ClCl here. That is called how to prepare alkyl halides from carbonyl. And tell me, is this geminal or is this vicinal? Because on one carbon you have 2 halides. So this is geminal halide. This is geminal halide. So with this, geminal halides are formed. Okay. With this, you have the formation of geminal halides, okay? Understood? Geminal halides are formed. Next is from carboxylic acid. Now, here what will happen? Just imagine this is not Roxa, this is the mother of Roxa, right? This is the mother of Roxa. Roxa was Rx, right? This is not Rx, this is RC double bond O, OAG. Silver salt of carboxylic acid. So it's not Roxa, you have mother of Roxa, right? So what will happen here? What will happen here? Everybody, what will happen here? So what will happen here? Here, this Ag and this Br2 in presence of CCl4 you will use, right? Now this silver salt of carboxylic acid will be converted to this Br, right? So what you can, what I ask students how to learn it, right? You can learn it by Bure Chor, right? Bure Chor. You can remember this by bad C for bad criminals, okay, bad criminals. I think because you know what, this is a very easy way to remember these things. So bad criminals will attack on the chain, silver chain. You have the silver chain, they will attack on the silver chain, they will take this silver chain with them, this is AgBr, and they will, you know, when somebody has taken out something from you, right, then carbon dioxide will be released because you will be so you know, sad because someone has taken the chain from you. And what you will be left with? You will be left with only bad memories. So here you will have bad memories, that is RBR. Just a way to remember, yeah. Okay, because there are so many reactions in organic chemistry, you will be able to forget everything, right? That's why I'm just telling you that this is how you can just remember something like this ma'am told us, right? Okay, okay guys. Now we are moving towards nucleophilic addition reaction, right? Preparation we have done, we are moving towards nucleophilic addition reaction. So are you all ready for nucleophilic addition reaction or not, everybody? Ready for nucleophilic addition reaction or not? Everybody in the chat box, everybody in the chat box. Let us see, firstly few things here. Let us see what is solvent, what is polar protoic, what is polar aprotoic solvent, right? So if you talk about the solvents here, right, if you talk about the solvents here, solvents are basically of two types. One is non-polar, other is polar solvent, right? So one is your non-polar solvent, other is your polar solvent. If you talk about non-polar solvent, that means there is no polarity difference here, like hexane, benzene, these are non-polar solvents. If you talk about polar solvents, you will have two kind of solvents. One is polar protoic, other is polar aprotic solvent. Just give me a second, right? Okay, one is polar protic, other is polar aprotic solvent. If you talk about polar protic solvent, that means it forms a hydrogen bond, right? And this no hydrogen bond is formed. This is polar aprotic solvent. This has a hydrogen, right? From where hydrogen bond it can form with that nucleophile, right? With that because you will have in the reaction, you will have one nucleophile, one solvent will be there, right? If you have a polar solvent, or you can say if you have a non-polar solvent, right, like these, or you can have a polar solvent which has polarity difference, but in this case that is also making hydrogen bond with the nucleophile, right, capable of forming hydrogen bond. And here like aprotic, like MECN, DMF, DMSO, they are incapable of forming hydrogen bond. So these are the kind of solvents that you have. You will, you know, understand the like role of these solvents when we will do SN1, SN2 reaction, right? Now, next is, what is this DMA, DMF, DMSO? So these are DMA, DMF, DMSO, right? They have polarity difference, but they don't have hydrogen, which can form hydrogen bond with the nucleophile. This hydrogen cannot form hydrogen bond. This hydrogen also cannot form hydrogen bond. this hydrogen also cannot form hydrogen bond. That means hydrogen is not connected to electronegative element. If hydrogen was connected to electronegative element directly, then it would have formed hydrogen bond. Then it would have been a polar protic solvent, right? Okay. Now, next is nucleophilic substitution reaction. So, let us see nucleophilic substitution reactions. So, basically these nucleophilic substitution reactions are of two types. How nucleophile will attack, how it will substitute the leaving group here, right? So, here, for example, this is your nucleophile, right? It is going to attack here with two different ways. What are these two different ways? That is SN1 and SN2 mechanism. What are these SN1, SN2 mechanism? I'm just going to write it here, SN1 and SN2. I'll just tell you here only what is SN1, SN2, right? Then we will see that in detail. This is SN2. What do you mean by 1 and 2? 1 means unimolecular. That means when we write the reaction rate in the slowest step, we know from chemical kinetics, rate is written by R, K, and this is the on which reactant it is dependent. So in SN1 reaction, it is only dependent on the substrate. But in SN2 mechanism, it is also dependent on the nucleophile. In SN2 mechanism, it is also dependent on the nucleophile. So this is your SN1 and this is SN2. This is SN2, right? Here it is bimolecular. 2 means bi, 2 molecular, right? Next is 1, 2, 1, 2. What is 1, 2, 1, 2? In SN1, you will have 2 steps. In 1, you will have 2 steps. In 2, you will have 1 step. 2 steps. See, here what will happen? Breakup will happen. Okay? Okay, has anybody faced breakup in recent days? He or she can relate to this, right? So now, just remember that SN1 is a loyal person. It is breakup is happening, it's a loyal person. It's a very toxic person. Okay, you can, in your language, I will write. Okay, in your language. Unimolecular is a green flag. It is a green flag. It is a green flag. It is a green flag. But bimolecular is a red flag. Okay, you know what is red flag, green flag. Okay, now SN1 is a green flag, SN2 is a red flag. So we will see how it is a green flag, red flag, right? So in SN1, what will happen? Firstly, you will say tata bye bye to your ex, right? Then you will sit alone and cry for some time. That okay, this thing happened with me. You listen to Arjit Singh songs, right? Then you will listen to some sad songs, right? You'll, just be sad for some time, some alone time. Then some nucleophile will come into your life. Then you will get attached to them. So you are the green flag. You are breaking up, but you are also sad that breakup happened. Now this is a loyal person, SN1. But SN2 is not a good person, right? Here what will happen? X has not left, but nucleophile is there. You are talking to nucleophile, but X is still there in your life. So it's a red flag. So X is still there and you are talking to nucleophile also. Then what will happen? What will happen, guys? What will happen? Then this is a red flag. Then one step reaction, that means transition state will happen, right? Here you are not in a cry zone. You are just transition from one to another. You're like, here I was with this X, now I am with this nucleophile. You were never alone. You just had a transition phase where you were ignoring the X and saying hello, hi, how are you to nucleophile. This is a transition state. But when we talk about SN1, there is formation of proper SAD mode. SAD mode means carbocation, electron deficient species, crying, deficiency of good things in life, right? So this will happen in your life. Carbocation you will become. Rearrangement will happen, definitely rearrangement. If you're a sad person, then you will rearrange yourself. You will learn some good things about other people. You will learn some lesson, and then you will have nucleophile in your life. Okay, understood? So that is a conclusion of what is SN1, SN2 reaction. Okay, understood? Now I think you will remember this. Now let's go through the mechanisms here. Okay guys, is that thing clear? Is that thing clear? Now let us see what is the mechanism here. Right, now let us see what is the mechanism. Shall I show you with this thing only, or do you want me to write it myself? Right, I'm just speeding up this so that that's why I have prepared the PPT before only, so that I don't want to waste your time here, right? So if you want me to write the particular mechanism, I can write as well. This is totally your choice. Okay, let me know in the chat box what you want. Now, as you can see, this is SN1. SN1 is red flag or green flag. SN1 means 2 steps, so it is a green flag. It is a green flag. But SN2 is a red flag. It is a red flag, right? It is like I will cheat with you. I am a cheater. I am a cheater, okay? I will not say bye-bye. I will not break up. I will chit-chat, right, with the other person also. So here this is Rx, right? On the first step, what will happen? Firstly, breakup will happen, right? This Rx bond will break, right? Electrons will be, right? I will remember lifetime. Now we know that from the, I want to draw it only, yaar. How to tell the mechanism in such a small way, right? This is Rx and this is your nucleophile. Here what will happen? This is SN1 mechanism. We know that X is more electronegative. Electrons will go. X will say, tata bye bye, I am taking everything from you, right? Then this will be very sad. R will be very sad. It will become R positive and this is X negative. It will leave. This is the first step. Then sometimes R will be like, okay, I am very sad in life. Then our friends will say that don't be sad, don't be sad. Talk to this nucleophile. Right, this is, wait a minute, here there is no entry of nucleophile. Na? Haan. This is no entry of nucleophile till now. There is no entry of nucleophile till now, okay. So here nucleophile we are going to add. Now nucleophile is going to react here and it is going to give us RNU, right, okay. So now what I am going to do, now I am going to make R some like, I'm going to make a group here of R. Let's say R is CH3. So that means this kind of thing will be formed here, right? That means this kind of thing will be formed here. This kind of methyl will be formed here, right? Now, when the nucleophile is going to attack here, nucleophile has only one way. Nucleophile is not having 2-3 ways here. Nucleophile can attack from only one side. It cannot attack from this side, right? Okay, or can it attack from this side? Everybody in the chat box, let me know. Can it attack from this side also or from this side only? Because see, in reality, it's like this. The CH3 group is like this. This is C positive and this is a planar species. It is having 3 sigma bonds. It is sp2 hybridized trigonal planar species. Trigonal planar species. So this planar species is going to be planar, right? Yeah, obviously, ma'am. So this is your nucleophile. This is your nucleophile. So nucleophile can attack from this side also, or nucleophile can attack from this side also, right? It's not like nucleophile will be like I am restricted to one side. Nucleophile can attack from this side also, this side also. That means 2 kind of products can be formed. So we want to make the product here. It can also be CHH. That means if I want to make the tetrahedral shape here, it can be this thing also. Or it can be CH, or nucleophile here also. These 2 things can be formed, right? These 2 things can be formed here. That means Either inversion can happen. See, if I want to draw the exact structure here, if I want to draw the exact structure here, this is H, this is H, this is H, and this is X, right? So if on the same position where X left, nucleophile is there, right? Here was X and here you have Nu. That means here you have the retention product. Here, for example, X was on this side, but now nucleophile is on the opposite side. That means inversion product also you have. So when you have these two products, both are formed, we say that racemic mixture is formed. Both stereospecific products are formed in this case. Okay, both stereospecific products are formed in this case. Is that thing clear to everybody or not? Is that thing clear to everybody or not? I am just showing you one molecule here to understand what is the stereospecific nature here. Okay. Just give me a second. Can you give me 1 minute, everybody? Okay. Now let us see this, what exactly happened here. Okay. Okay. Shivu, I just joined this channel. That's why the classes are less. Okay. Okay, are you able to see this structure? This is the tetrahedral structure. Now, I am saying that, for example, initially it was like this. I am saying that initially this was hydrogen, 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 and this is your halogen. Right? Initially it was like this. Now, I am saying after this what happened? The X negative will leave and it will become, now we know that here it has 4 sigma bonds, that is why tetrahedral shape. It has sp3 hybridization, tetrahedral shape, right? But once it will lose the halogen here, it will have 3 sigma bonds. Because of these 3 sigma bonds, it will become like this. It will become like this. It will become trigonal planar. Can you tell me why? Because now it is having sp2 hybridization. That is why it is trigonal planar, right? That is why I have drawn this thing here. I have drawn this thing here. Now it has 3 hydrogen and this is the carbocation. Now 2 things can happen. This is my nucleophile. It can attack from this side. It can attack from this side. It can attack from this side. Anywhere it can attack, right? So I'm just assuming that it is attacking from this side and or this side. So what can happen? What are the 2 things that can be formed here? Okay. So let us see what are the 2 things that can be formed here. Okay guys, let us see that. Let us see that. Okay. So earlier this was the tetrahedral shape that I was telling you. This is the tetrahedral position that it was in. Right? This is your X. Now X has left, intermediate has been formed. Now what if the final product is on the same position? It's like this. Then we can say that it has attacked from the same side. This is the retention product. What if it is not on the same side? What if it is actually like this? What if the product is opposite? It is like this. Now this is the inversion product. Now it has attacked from the opposite side. Earlier it was on this side, now it is on this side. Right? So this is the inversion product. And when you have both the things, then we say it is a racemic mixture. Okay guys? Then we say it is a racemic mixture. Where is the pen? Okay. Then we say it is a racemic mixture. Right? Okay. Now, on this is the slowest step and this is the fastest step. So in the slowest step, you have only the substrate. That is why it is called SN1 mechanism, because it is dependent on only on the substrate, not on the nucleophile. Right? Now let us talk about SN2 mechanism. Now let us talk about SN2 mechanism. Right, SN2 mechanism. One more thing to note down here, that when you have the formation of carbocation, then remember the stability will be according to the carbocation. So the stability order will be 3 degree, then 2 degree, then you have 1 degree. And you will see your JEE mains and advanced questions are based on these little things that I am teaching you. Right, okay. Next is, if you have a alkyl halide and nucleophile is attacking. So now here nucleophile will attack, right? Here nucleophile will attack, and what will happen in this case? Nucleophile is going to attack here, but X has not left, but the nucleophile is attacking. For example, I'll draw the X here so that I can make it easy for you to understand, right? So now X is attacking from this side, right? And wait a minute. Hydrogen should be here, X should be, okay, just to make it easy for you. For example, nucleophile attacking on this side. Now see, this is the halogen. This is the halogen that you have. See one thing. Halogen is attached from this side. Halogen has not left yet. So halogen would not want any nucleophile to attack on the carbon, right? That is why it has to attack from the opposite position, right? That is why if halogen is present here, it will attack from the opposite position. That means if this is your halogen that is present here, then nucleophile will attack from this position, not from this position, because here already halogen is present, right? So that is why it will give you the inversion product, right? So it will attack from the opposite side, and here what you will get, there will be a transition phase, right, where the halogen will get to know that carbon is cheating. Carbon is cheating because of the nucleophile, right? So here what will happen? At one point you will have the formation of this transition product where nucleophile is getting attached here, but halogen bond is getting weak here, right? So this is the transition state. This is the transition state that is formed. And after this, what will happen? You will have the formation of this nucleophile here, and this is hydrogen, this is hydrogen, this is hydrogen, and this is the new nucleophile. Earlier, the halogen was present here, now nucleophile is present here. As you can see, this is the halogen and this is the nucleophile. So, can you say that there is inversion product is formed? Inversion product is formed. Inversion product is formed, right? Second thing to note down here, that inversion product is formed. And what else? Yes. Now as you can see, the slowest step has both the nucleophile and the substrate. So that is why it is SN2 mechanism, right? Now it is not forming any carbocation. Ma'am, what about steric? Yeah, that's what I wanted to say in the next step. And the next point was steric hindrance only, because here you don't have carbocation. So the stability is not dependent on the carbocation. The stability is dependent on the steric hindrance, right? So this nucleophile wants to attack. If there is large groups already present here, it will be very difficult for nucleophile to attack, because it has halogen, it has so big groups. That is why nucleophile, it will find it very difficult to attack. So we know that steric hindrance is less than 1 degree, then you have 2 degree, then you have 3 degree. Hence the stability order is opposite, right? That is the reason. I'll tell you now why some reactions prefer SN2 mechanisms and some will prefer SN1 mechanism. Okay? Understood this thing? Everybody in the chat box? Everybody in the chat box? Now let us see all the points here. This we have done two-step process. Firstly, this will happen. This we have done. Racemic mixture will be formed. right? And here inversion product will be formed. Next is rate. In SN1, it is dependent on only on the substrate, right? But here it is dependent on substrate as well as the nucleophile. Molecularity. Molecularity, we know that it is unimolecular because it is dependent on only one substrate. It is bimolecular because it is dependent on nucleophile as well as the alkyl halide, that is the substrate. Intermediate. Here the intermediate is carbocation, that is why rearrangement is also the important factor here, right? Here the intermediate is the transition state, right, that is formed here. Next we have stereochemistry. Here you have the racemic mixture that is formed here, retention and inversion. Now you need to understand one thing, that this question can be asked, and possible excess inversion. They can also ask you, yes, in SN1 mechanism, racemic mixture is formed. But in racemic mixture also, which is more? Inversion thing is more as compared to retention. Right? Inversion is formed more as compared to retention, because obviously, even if carbon is single now, still this nucleophile will not try to attack from the same position where the halogen was present, right? So more will be the inversion, but there will be both the things, right? Okay, both things will be there, but more will be the inversion product, right? Next is, here you have the Walden inversion, purely Walden inversion is present here, right? Then you have TS of slow step. Transition state is dependent on the slowest step. TS transition state of slowest step is this one. That means they are saying the slowest step is this one. Here the slowest step is this one, right? That you don't, they are saying that in the formation of do you say, ma'am, SN1, how come you are saying transition state? In SN1 also, before making the carbocation, it has went through some transition state, and this is the transition state, right? Okay, this is the transition state when carbocation was alone, right? It is the transition state where nucleophile is attacking on both the sides, right? And here this is the transition state, this so we have seen only, right? Next is the reactivity. Now this is important, that why benzyl and allyl? We know that in benzyl there is resonance, again there is conjugation here. See, in resonance, benzyl means you will have this kind of carbocation, you will have, right, which is stable due to resonance. Allyl means you will have this kind of carbocation, it is stable due to conjugation. Then you have 3 degree, then 2 degree, then you have 1 degree, then you have methyl. Okay, understood? So that is why these two things. It is stable due to resonance, it is stable due to conjugation. And we talk about the stability of the carbocations, right? So that is why benzyl, then allyl, then 3 degree, 2 degree, 1 degree, then you have methyl. Very, very important order. Very, very important order. Here you have methyl because of less steric hindrance, then 1 degree, then 2 degree, then 3 degree. Again, a very, very important order. Nature of leaving group. If you talk about the nature of leaving group, right, it depends on that also. Whether it's a good leaving group, it's a bad leaving group. So Viken's base is the best leaving group. That means weakest base. Basicity. Now you need to tell me, ma'am, which is more basic, which is more acidic. Ma'am, why here the basicity order is like this? Okay, why the basicity order is like this? See, this is down the group. Whenever you talk about down the group, right, the basicity order is because fluorine is very small, right? That is why it has a large electron density, right? That is why its nucleophilicity is very high, but its basicity is very less, right? Okay, so what you need to remember, this is the basicity order, and the weakest base is the best leaving group here, right? But here the weakest base is the best leaving group here also. Okay, okay. Rearrangement occurs, rearrangement does not occur except for allelic. Now, next part is I'll tell you these points, right, in detail. Okay, just wait for some time. Let me complete the table first, then we'll talk about the how to identify, and weakest base, all these things will come in that zone only. Catalysis. So it is catalyzed by heavy metal ions, Lewis and Bronsted acid like AlCl3, ZnCl2, strong acids, right, Ag positive, Pb positive. Phase transfer catalysts like these are required, or crown ethers are required in SN2 mechanisms, right? Okay, so whenever you see these kind of catalysts, that means it is SN1. When you see crown ethers and these quaternary ammonium salts, and these are your SN2 mechanisms. Determining factor, stability of this and steric hindrance of this. Solvent effect, this is the most important thing that will tell you. This again, it's not so important, but this is the most important thing, right? So I'll tell you what exactly about these solvent thing, right? For solvent, what you need to remember, rate increases in polar solvent. You require polar solvent here that used to form hydrogen bonding. Rate is directly proportional to the hydrogen bonding ability of solvent and dielectric constant. Don't go for dielectric, just remember polar protic solvent is required here. Polar protic solvent. Just remember this thing. And here polar aprotic. Depends on the nucleophilic reactant, uncharged species. Either both nucleophilic reactant are charged. The rate decreases with increase in solvent polarity. That means polar aprotic solvent. You don't need to remember any of this. Just remember polar aprotic solvent is required. Right? Polar aprotic solvent is required. Right? Okay. Now, rate increases as DMSO, then DMF, and then acetone. Depends. See here, polarity is increasing. That is why rate is decreasing. Right. So as the polarity increases, rate decreases, which also is written here. Right. Rate decreases with increase in the solvent polarity. Right. So this type of solvent leaves free the most reactive nucleophile. Right. Okay. Understood. Now, then is effect of nucleophile. First is we have talked about solvent effect. If you have polar protic solvent, it is SN1. Polar aprotic solvent, it is SN2. Simple. Okay. Then if you have effect of nucleophile, whether it's large, small, what kind of nucleophile. Concentration of nucleophile has no effect on the rate of reaction. It does not appear in the rate equation, because in the rate law, you don't have, it is only dependent on the alkyl halide. But here it depends. So greater the nucleophilicity, faster is the rate of reaction. More is the nucleophilicity, more is the rate of reaction. That means more electron density on it, more it wants to get, more electron density means it is more attracted towards the positive side. So more is the nucleophilicity. So more is the nucleophilicity, more will be the SN1, SN2 reaction, right? Okay. Then you have nature of nucleophile. Nature of nucleophile means for HNU solvent rate, basicity of HNU. Now here this is important for you, and this I will tell you. Okay, just give me a second. Right. Now here, basically, if you talk about nucleophilicity and basicity, no, so they are sometimes directly, they are sometimes inversely. Okay, so I'll tell you in a very short manner. Okay, I'll tell you in a very short manner. So you have three things. Okay, first it is divided into two. One is down the group. First is along the period. Along the period. Then you have down the group. Down the group. Right. So along the period, if you have all the nucleophiles along the period only, then basicity is directly proportional to nucleophilicity. Nucleophilicity, right? Then basicity is directly proportional to the nucleophilicity. Okay, just give me a second. Okay. Now, if you have polar aprotic, here it will not matter what is the solvent. It will not matter along the period. But down the group it will matter whether the solvent is protic or aprotic. If the solvent is aprotic, that in that case it is directly proportional, same as this one. But if the solvent is protic, now this is the important thing, then it is inversely proportional. Basicity is inversely proportional to the nucleophilicity. Right? Okay. So this is the overall thing that I have told you. You know what is aprotic, you know what is protic. Right? So if it is, they are comparing the nucleophiles along the period, then it doesn't matter what is the solvent you have. Basicity will always be directly proportional to the nucleophilicity. More is the nucleophilic character, more will be the basicity. But if it is down the group, like fluorine, chlorine, bromine, iodine, right? In that case, it will be aprotic or protic, it depends, right? If it is aprotic solvent you have, like you have, let's say, you have DMSO, right? In all these things, it is directly, but if you have protic, like water, right, it is inversely proportional, okay? Yes, everybody? Yes, everybody? So here let us understand this thing now. From this chart, I feel this will be easy for you to understand what they are saying. For H and U, this is a nucleophile, rate is directly proportional to the nucleophilicity of this one. Right? They are saying that here rate is directly proportional to the nucleophilicity, directly proportional to the basicity of H and U. This is in case of SN1. But if we talk about a protic solvent, rate is directly proportional to basicity. In protic solvent things will change. When same nucleophile site and belong to the same group, then in the periodic table, same group, that means we are talking about along the period. Here it is along the period. See, it is along the period. It's just that here it is written in a theoretical manner, so it is difficult for understand. So I'll just make it easy for you. This is along the period, and this is along the period, and this is down the group. This is down the group, right? So they are saying if they belong to the same group, that means they are changing along the period. In that case, periodic table rate is directly proportional to the basicity. Have we done the same thing? Along the period, basicity is always directly proportional to the nucleophilicity, right? Then that means rate is dependent on the basicity of nucleophile, right? Now when different, now they are saying that when different nucleophile sites and belongs to same periodic table, right, group, right? Now they are saying that when different nucleophilic sites and belong to the same periodic table group. Wait a minute, this is also same group only. Same group or period? Same periodic table group. Same group means it is down the group again, it is down the group only. It is same group, that means it is down the, not along the period, this is also down the group only. Wait a minute. Both are down the group only. Same periodic group, the rate is directly proportional to the polarizability of nucleophile. Okay. So here they have written something different, right? I was telling you, I thought they had taken this point only. This is a different point, right? This is a different point. So I'll tell you. Basically, they are talking about the protic and aprotic nature. This is not very useful, but still I'll teach you what is this. So basically, they are saying that in a protic solvent, rate is directly proportional to the basicity of the nucleophile, right? Basicity of the nucleophile will be dependent on these things, right? They will be dependent on these things. I know right now you're finding that, ma'am, what you are talking about. I'll give you examples, then it will be very easy for you. I'll just give you 1-2 examples. It will be like very easy for you to understand. Just understand one thing, that here in case of when you have aprotic solvents, because it depends on the solvents. Aprotic means like you have DMSO, right? All these solvents. Rate is directly proportional to the basicity of the nucleophile. What is the basicity of the nucleophile, right? Whether it's very basic or less basic, it depends on that. Now, here in protic solvent, which is forming hydrogen bonding, right? What will happen when same nucleophile site and belongs to the same group? It belongs to the same group, down the group fluorine, chlorine, bromine, iodine, and it is having same nucleophilic site. In that case, rate is directly dependent on the basicity of the nucleophile. But when different nucleophilic sites, right, in the same compound, but you have different nucleophilic sites and belong to the same periodic table group. That means, for example, halogens, for example, oxygen family, they are belonging to the same group, right? But the different nucleophilic sites you have, right? Different nucleophilic sites, then rate is dependent on the polarizability of the nucleophile, not on the basicity. Polarizability, that means how much electron density it has, how much polar it is, right? How much it can donate the electron cloud, right? That is the polarizability of nucleophile. See, a nucleophile can be a base, it can be a nucleophile also. When a nucleophile is acting as a base, that means it can accept H positive, right? It can share the electron density. If it is acting as a nucleophile, it will attack on the carbon positive here, right? This is what is difference between base and nucleophilicity. So if you're belonging to the different nucleophilic sites and belong to same group, then rate is dependent on the polarizability of the nucleophile, how much electron density it has, right? Okay, so now I'll tell you what is the application of these two things here. The application is, I'll write here, the application is to identify which is SN1, which is SN2, which is SN1, which is SN2, right? So we will only talk about the nucleophiles, we will only talk about the nucleophiles here. Okay, so I am going to write few things here, right? Just remember these things here. So SN1, basically SN1 is dependent, it is polar protic solvent it needs, right? So polar protic solvent means it will be having solvolysis, right? Then it will be Ag2O, right? Moist Ag2O, right? Then you have AgNO3, aqueous AgNO3. So these are in your exam that they can ask you. This is moist, okay? If you see solvolysis, that means polar protic solvent if you see anywhere, right? Then you can simply say SN1 reaction. But 3 degree or 2 degree, 1 degree will not show. If you have 1 degree and you have these kind of reagents, then it will resist SN1 reaction. But if you have 3 degree, if you have 2 degree, definitely they will show SN1 reaction. 2 degree is always intermediate between SN1 and SN2. Same thing is with this one, 1 degree, then 2 degree, then 3 degree. If you have 1 degree, it will always prefer the SN2 mechanism. Okay, so I'll just show you here what can be formed, right? If you have a very strong nucleophile, right? Like I negative, like yes, I negative is a very good nucleophile. Yes. Okay. So if you have very strong nucleophile, OH negative, this is also very good nucleophile, right? So it will show SN2 mechanism, right? Okay. Okay, everybody. Now, why does SN2 reaction always lead to inversion? This though I told you SN2 mechanism because it is a one-step mechanism, no? So it doesn't have any site. So it can only attack from this position. It can only attack from this position. It cannot attack from this position because already a very good group is there, right? So that's why it's only inversion product. So yes, I negative NH3 you can say with lone pair of electrons, right? So because for OH negative, it will depend that what is the condition that you have, right? So depending upon these two things, you will have the answer as whether it is SN1, SN2. I'll show you some question based on that we can see. That is why I'm saying that this is not that useful, right? You can skip this point as well, but this is useful for you. This thing is useful for you, right? If you have a very good nucleophile, right, which is having very good polarizability, right, then it will be your SN2 reaction. SN1 is solvolysis, you have moist AgO, Ag2iso, you have aqueous AgNO3, that will show you SN1 reaction. Okay, okay, so now I think we'll do some questions here based on this only, right? Based on SN1, SN2 only. I'll show you some questions here. Let me see your JEE questions only. Okay. Let me see, yes. So based on these, let us see some questions, okay? So that you are able to understand what kind, why I was like, why these questions are important, what kind of questions are asked, right? So the correct statement regarding nucleophilic substitution reaction in a chiral alkyl halide. If you have a chiral alkyl halide, what is the correct statement regarding nucleophilic attack? So nucleophilic attack you have, they are saying retention in SN1. SN1, you have two steps, so there is racemization, not retention. Racemization in SN1, racemization in both, no. Racemization occur in SN1, inversion occur in SN2. If they are saying retention will occur in SN2, no. So D is the correct answer, racemization in SN1, inversion in SN2 reaction. So D is going to be the correct answer. That is a simple question directly from your points, right? So that is a simple question directly from your points. Let us see some other questions regarding SN1, SN2. I think this one. This one I was talking about. That on the basis of nucleophiles, not nucleophiles, on the basis of alkyl halide, they can ask you this reaction, this kind of question, right? Because knowing the like basicity, acidity, rate dependence, they will not ask you these kind of questions, right? So they will ask you these kind of questions. This is your JEE 2024 questions. Which among the following halides will not show SN1 reaction, right? Which will not show SN1 reaction. For SN1 reaction, you should have a stable carbocation. You need to see what kind of carbocations will be formed here. Here you will have this kind of carbocation which is allylic, and the allylic carbocation is very stable. Here you will have a benzylic carbocation, again it is very stable. Here it is having a 2-degree carbocation, again it is somewhat stable, right? But here it is forming this kind of species, CH3, CH, double bond, CH. Now this is the most unstable carbocation, right? Basically they are not asking you SN1 reaction, they are asking you the stability of carbocations, right? So answer will be B only. It will not show SN1 reaction because an unstable carbocation is formed here, right? Then now let us see other questions based on this. This question is based on, no, this is not based on the, just give me a second. This one I think. Electrophilic substitution also not. Yeah. This is the next question based on SN2 reaction, right? Okay. Because you have just seen the SN1, SN2 difference. That's why I am telling you that what kind of question they can ask you. Which among the following compounds undergo SN2 reaction, right? SN2, guys, we know that it is one step here, transition state is formed. Transition state is formed. So you need to tell me which is having SN2, sorry, it is one step only, right? So which is having compound will undergo fastest SN2 reaction. Now where your steric hindrance is less, where steric hindrance should be less. Steric hindrance less. We need less steric hindrance. So if it loses, Here if nucleophile wants to attack, this is carbon is connected to 2 more carbons, it is 2 degree. Carbon is connected to, this carbon is connected to 1, 2, 3 carbon, it is 3 degree. Here it is carbon is connected to 1, 2, 3, 3 more carbon, again it is 3 degree. Here carbon is connected to only 1 carbon, this is 1 degree. So 1 degree is the least hindrance, so A will be the correct answer. Okay, so this is based on those factors. Now I'll show you some good questions here for SN1, SN2, right? JEE Advanced also we will see. Let me see if I have put any question of JEE Advanced from nucleophilic. SN2 reactions are stereospecific, indicating that they result in formation of any one stereoisomer as the product, right? So SN2 means there is transition state. Transition state means it can be only inversion product is formed here. They are saying it is stereospecific, indicating that they result in the formation of only one. Stereospecific means only one isomer will be formed, either inversion or retention. So yes, inversion product is formed. That means stereospecificity is right here. SN1 reaction generally react in the formation of product as racemic mixture. SN1 means carbocation. Carbocation means from both sides. So that means inversion and retention, both product will be formed. So both 1 and 2 is the correct statement, right? Both 1 and 2 is the correct statement. Okay, understand? Now let us see some more question based on this. Okay, let me see if this is a question of I think that's it. Let me see if there was any other question belonging to this thing. I think okay, I think that was it, isn't it? Yes. So I think that's it. These were the questions from SN1, SN2, right? So now let us go to the same section again, right? That is this one, right? Now let us see some other reactions. Now, do you want me to complete the chapter today only? Guys, do you want me to complete the chapter today only? If you want me, then I need to speed it up, right? Now, substitution by OH, right? Some major things that we have done. Now we are left with very little things, okay? So substitution by OH group, right? Okay, substitution by OH group, that means if you want to substitute the OH group from here, see, remember one thing, whenever you want substitution, then you need aqueous KOH or NOH. Aqueous protic solvent will be present here, and in protic solvent what you have, right? Aqueous, moist, this what you have is protic solvent, so it will proceed by SN2 mechanism, that is carbocation formation. The SN2 mechanism, no. Wait a minute, something is wrong here. This proceeds to SN2 only, yes. This will proceed through SN2 mechanism only, right? Okay, so yes. So this is your, wait a minute, what I have written here, there is some confusion. AgNOT, SN1 it is. Is it moist? It should be SN1 then. It should be SN1 then, right? It should be SN1 then, right? Wait a minute, guys, just give me a second. SN1, 2 degree proceed to SN1. Okay. Okay. Now let us see why this is proceeding through SN2 and why that through SN1. Very important thing here. As I told you, you also need to focus on the alkyl groups here, right? So if you can see here, I told you one thing, that if you have moist Ag twice, solvolysis, then it will proceed to SN1 reaction only. But if you have 1 degree, then it will not proceed. Why? Because rate of 1 degree, because of the less stable carbocation, it is very less. Right? That is why it will not proceed to 1 degree, but it will proceed to this. Now, here they are saying that here substitution is occurring by SN2 mechanism, but in this case you have 1 degree alkyl group. 1 degree alkyl group. You don't have 2 degree or 3 degree. So if this is 1 degree, here you can write R is 1 degree. Right? So then what will happen? It will proceed by SN2 mechanism, that is by steric factor it will go. Right? So here you have NaOH, you have KOH, you have AgOH, AgOH twice. Though these are polar protic solvents, right? Even though it will go via SN2 mechanism because of the alkyl group, that is a primary alkyl group. It is 1 degree, it is 1 degree, it is 1 degree. Right? That is why it is going via SN2 mechanism. But here, as you can see, if I substitute R as the 3 degree alkyl group, right? Now it is 3 degree, as I have told you the chart here, It is 3 degree, but it is also Ag twice, so AgNH2. Now that is why for sure it will go through SN1 mechanism, that is by carbocation formation. Right, so it is by SN1 mechanism, by carbocation formation. Understood this thing? Okay. Okay guys, understood one thing, that it should be either S1 or SN2, right? 3 degree, 2 degree, 3 degree, so definitely it is SN1 only, carbocation formation. 1 degree is definitely steric hindrance. 2 degrees intermediate between both of them. It depends on the reagent, that where it will proceed towards, right? Okay. Now that was just an example of showing you. They can also give you these examples as well. They can also give you any solvolysis product or AgN aqueous AgNO3, anything they can give you, right? But you need to see the alkyl groups also, right? What they will prefer, okay? What they will prefer. Now, next one is substitution by OR group. So now you have NaOR, right? Now, this is our attacking nucleophile. Then what will happen? This is positive, this is negative, this is positive, this is negative. ROR, that means ether will be formed here, right? And the ether formation we have done in alcohol phenol ethers also, the Williams synthesis in detail, right? We have done this, right? Now they are saying if dry Ag twice, here we have not used moist, it is dry, it is dry Ag twice. So now if you definitely have dry, then it doesn't matter what you will have, it proceeds via SN2 mechanism. Alkyl halide should be 1 degree, right? SN2 means transition state is formed here. Now here you have the dry Ag twice so, right? A dry Ag twice so, right? Then it is proceeding via SN2 mechanism, definitely, right? Then we have the next one is C2H5ONA, right? Now this is your alkyl halide, this is C2H5ONA. Now this thing will attack on this position and you will have the formation of CH3CHOC2H5, right? And this is CH2CH3. That means here you will have the formation of ONA, right? Okay, and this product will be formed as the major product. Now there are two things that you need to understand here, right? SN2 means it is via transition state, it's happening here, right? So now in this case, this is CH3, CH2. That means here you have, wait a minute, this is CH3, then you have CH3. There is some shift that has happened here, right? And in this case, what is the minor product? To this thing directly you have attached OC2H5, right? Directly when you have attached, this is OC2H5. But here what you have done, to this, you have shifted the reaction here, right? Okay, this C2H5 has been shifted here, right? After that, this is your major product that has been formed, right? So this becomes your major product, right? Again, that rearrangement only we are telling about. Now, this is the question that has been asked in your JEE Advanced, not JEE Advanced, it's JEE main question, right? Let's talk about ambident nucleophile. If you talk about ambident nucleophile, that means they have two sites, right? So if you talk about KCN and NaCN, this is also C and N are the two sites from where it can attack. Now KCN is forming a ionic bond, right? That is why this is ionic bond, this is existing in ionic bond, and this is existing in covalent bond. So in covalent, this C is not free, that is why it is attacking through nitrogen. Here the C is free, that is why it is attacking through this carbon. That is why here you have the formation of cyanide and here you have the formation of isocyanide, right? So attack from carbon side of CN and here attack from nitrogen of CN because of the ionic and covalent nature. Same is when we talk about KNO3 and AgNO3. This is ionic in nature and this is covalent in nature and this is covalent in nature. That is the reason, because it is ionic in nature, it will attack from this bond. You will think that it is nitrogen, but it is attacking like this, okay? This is K positive, NO, NO2, and here it will have the positive, negative, sorry, right? So that is why from oxygen it is attacking. But when you talk about this thing here, right, this is covalent in nature. That is why what will happen, for example, this is your KONO, right? So here what will happen, this is positive, this is negative. So it will attach from this oxygen only. But in this case, this is covalent in nature. That is why this bond is not free. This element, this nitrogen is free to attack. That is why here you will have the attachment from nitrogen. And hence the attack of nitrogen occurs in case of AgNO3 and attack from oxygen occurs in case of when you have KNO2, right? So it depends what you have, right? Okay. Now, next thing is substitution by amino group. So this also we have done the same reaction we are repeating. Ammonolysis or alkylation of ammonia. This is the same thing, we have done this already, right? 1 degree, 2 degree, 3 degree, then quaternary ammonium salt will be formed here, right? Next is substitution by salt of carboxylic acid. So you have the salt of carboxylic acid. You are adding any alkyl halide here. What will happen, right? In the presence of ethanol and heat, what will happen? You will have the formation of this negative, this positive, this negative, this is positive, right? This is negative, this is positive, this is negative, this is positive. This R will attach here and hence you will have the formation of ester in this case, right? Ester will be formed in this case. Now, if you have substitution by RC triple bond C, if you have a triple bond here, this is positive, this is negative. Yes, this is positive, this is negative. So, R is replaced by this Na, right? R will replace this Na and hence you will have the formation of higher alkanes. And this reaction is also very, very important when we talk about chain reactions that are usually asked in JEE, right? Chain reaction, they will give you a set of reaction A, B, C, D, E product is formed. What is C product? What is E product? Right? From there, this is frequently asked, right? That a triple bond, if you want to increase the alkyl chain, then you can react it with Rx and hence negative will go to positive, positive to negative. What you have to do? Negative, positive, negative, positive, right? Then you have dehydrohalogenation reaction. Now from alpha and beta position, alpha hydrogen and halogen will be eliminated. For example, from alpha position, X negative will be eliminated. Then this bond will shift here and H positive will eliminate from this side and hence you will have the formation of alkene. But in this case, you don't have aqueous base, but you have alcoholic base, right? For example, you have alcoholic QH and heat, right? So aqueous is used for substitution, but alcoholic is used for dehydrohalogenation reactions. Okay? Okay? Now, here again there is anti-elimination that will occur, right? That means you will have the anti-elimination, not addition, right? Hydrogen is getting eliminated from this side, halogen from this side, hydrogen from this side, right? And hence there will be a transition phase that you will have here, right? A transition phase will be formed, and after that you will have the formation of alkene in this position, right? Okay. Now the question arises, which will be the major product, ma'am? Major product. So that is according to the Sedgwick rule. More substituted, highly substituted alkene will be the major product. If you see here, this alkene is having two alkyl groups. This is more highly substituted. This alkene is having only one alkyl group. That is why this is minor and that is the major product, right? Next is, yeah, this I have already told you, Sedgwick rule, right? Now next is Wood's reaction, right? Okay, what happened? What is not clear? Which is not clear to you? Which thing is not clear? Now, let us see Wood's reaction. So, in Wood's reaction, simply double alkene will be formed, right? So, what will happen here? You have Rx, you have Na in presence of dry ether that will act as a solvent, you can say. But here, because sodium is very reactive, that is why we have to add dry ether here, right? And here dry ether is used because ether is again, you can say sodium is reactive, that is why dry ether is used, not moist ether is used, because sodium is very reactive towards water, right? So that is why dry ether is used, and ether is acting as a solvent, you can say, which can help the solvolysis of sodium, so that energy can be produced here, right? So here Na we have done. Here we will have free radical mechanism. Here free radical mechanism is used. Again I am telling you, in hydrocarbons we are going to do alkanes and alkenes on the first lecture of hydrocarbons. There in detail I will discuss about Wood's reaction, because this is intramolecular Wood's reaction, 1,2 addition of Wood's reaction, right? Intermolecular Wood's reaction, all of those things we will discuss, because that itself is a very big topic, right? We will discuss about the Wood's reaction, everything related to that in hydrocarbons alkane part. That will be the next lecture after this, right? That is going to be on next week, right? So here I'll just give you just overview of this thing, because this is a question of your hydrocarbons. Dry ether is used and you have double the alkane is formed, and here unsymmetrical alkanes are not formed, only symmetrical alkanes are formed. Unsymmetrical alkanes will give a mixture of products, that is why it is not formed here. Like you have CH3 here, so CH3 will be formed. You have C2H5 here, so C2H5 will be formed. Tertiary halide do not undergo this reaction. If you have any tertiary halide, that will not undergo this particular reaction, right? Okay. Next is Frank-Land reaction. Again, it is same as Wood's reaction, similar to that, but here we used zinc, right? So here Rx instead of sodium we will use zinc, and here again the double the alkyl chain is formed. Okay, double the alkyl chain is formed, and this reaction is also not for unsymmetrical alkenes. But now we have the next reaction, that is your Corey-House synthesis, right? Corey-House synthesis. Now this reaction is applicable for unsymmetrical alkenes as well, right? This is the only reaction. Like firstly, Wood's is not applicable for unsymmetrical, Frank-Land is not applicable for unsymmetrical, but Corey-House synthesis is applicable for unsymmetrical preparation of unsymmetrical alkenes as well, right? So here you have Li, here you use Gilman's reagent. So Gilman's reagent, this is your Gilman's reagent. R2CuLi, yes. This is your Gilman reagent. This is your Gilman's reagent, right? Gilman's reagent is used here, and this Gilman's reagent will react with the alkyl halide. This is R dash, this is R. They will together can form R dash. That means unsymmetrical can be formed. Unsymmetrical alkanes you can form from Corey-House synthesis. Okay, that is an important factor for Corey-House synthesis, If they can ask you out of the following, which can form Corey house synthesis. So these all are no organic compounds only. Even in Franklin reagent, we used organic compound, right? This was the organic compound that was formed here, right? This here you will have formation of the organic compound, that is ZnR2. ZnR2 organic compound was formed here, right? So here also this is also organometallic, not organic, organometallic compound. Another organometallic compound is Grignard's reagent. That means here you have RMgX. Grignard's reagent is very, very reactive in case of water. It reacts very easily with the water. That is why here always you will use dry ether. Always and always you will have dry ether here. Always. Because it is very, very reactive towards water. It will form alkane in case of whenever we add water. Even if it has just moisture there, it will form alkane from that. Alkyl halides on reaction with Mg, what will happen? Between this R and X, you will have the addition of Mg, and this Grignard reagent will be formed. And this Grignard reagent is a very, very useful compound. We know that we have done the reaction of Grignard reagents in haloalkanes, in alcohol phenols also we have done. In carboxylic acid aldehyde ketones, we have done the reaction of Grignard's reagent. Right? Okay? Yes? Yes, everybody? Now, next is haloarenes. Let us see haloarenes. What are these haloarenes? Right? Okay, let us see haloarenes here. Haloarenes are basically, when you are talking about to this benzene, the halogen is attached, that is called haloalkenes, right? So if you want to prepare from benzene directly haloarene, just add Cl2 and FeCl3. This is a Lewis acid. That is why it will produce Cl positive electrophile that will attack on the benzene, and hence you will have the formation of the chlorobenzene, or you can say halobenzene. That is called haloarene. Right. So what is the mechanism here? How it is formed? Firstly, you have the formation of Cl positive electrophile. Then this electrophile is going to attack on the one position. Right. It will attack here. Then we know that because this pi bond has, we have broken this pi bond here. So here you have positive and here you have the attachment of Cl positive. Right. Now what will happen? There will be resonance that will occur. Right, again there will be resonance that will occur. Now from here we will also add H, we will also take out, I would say, yes, we will also take out H positive. This is stable pi complex that will be formed here, which will have positive charge on the ortho and para position. Right, then after that we will remove Cl from here, we will remove H positive from here. This electrons will shift here and hence you will have the formation of chlorobenzene here, right? Now, next is from hydrocarbon, how can we prepare the chlorobenzene? See, if you talk about this toluene, we know that toluene is a ortho-para directing group, right? This is a, because overall it is showing plus M effect, not plus, you can say it is activating. Right, that is why it is ortho-para directing. So at the ortho and para position, you have positive charge. Right, sorry, you have at ortho and para position, you have the negative charge. So it is ortho-para directing. So electrophilic substitution reaction will occur at ortho and para position. Para being the major product here. Ortho and para directing groups, these are the ortho-para directing groups like CH3, C2H5, and which has, that means alkyl groups are ortho-para directing, and the ones which have lone pairs on that atom are ortho-para directing. What are meta directing groups? When that benzene ring is directly connected to a atom which is double bondedly connected to more electronegative element. Oxygen is more electronegative, this is less electronegative, so it will take out the electrons from here. So that is why it is meta directing, that means it is going to show minus M effect. Here they are going to show plus M effects, right? Next is if you have AlCl3, right? If you have AlCl3 in presence of I2, right? What will happen? You will have the formation of I positive as the electrophile. It will attach and hence you will have the formation of this idobenzene, right? Okay, idobenzene will be formed. One very important thing for this one is idobenzene is formed because from this I2, you will have the formation of I positive and I negative. That means idobenzene is formed here. That too we know. But the next important thing is HI is formed along with it because here hydrogen is replaced also and here you have I negative. So HI is eliminated from here. But HI is a very strong reducing agent, reduces idobenzene to benzene. That means reversible reaction occurs. That means reversible reaction. That's why I was telling you with iodine, always reversible reaction will occur. Reversible reaction will occur. That is why we need to add a very strong oxidizing agent here to lower down the power of this HI because it's a very good reducing agent. If we add good oxidizing agent, then the power of this reducing agent, reducing character of this HI will decrease. That's why we need to add some good oxidizing agent like HiO3 or concentrated HNO3. These are good oxidizing agents like concentrated HNO3 or HiO4 are added here so that this reaction cannot be reversible, right? Fluorobenzene cannot be prepared by this method. Idobenzene still we can prepare if we add strong oxidizing agent, but fluorobenzene is very explosive in nature. That's why it's very difficult to prepare that, right? But there are other methods to prepare fluorobenzene, idobenzene. That is by the formation of this benzene disonium chloride. This also we have seen in amines as well. I am just revising this thing because I know this we have done like in previous 4 chapters we were doing this thing only, right? So this is very reactive. Now what will happen if you want to form chlorobenzene from here, then what you need to do? You need to do Sandmeyer reaction. What you need to do? You just need to add the salt here. CH2Cu, wait a minute, yes, Cu2Cul2HCl or CuClHCl, right? Or Cu2Br2HBr or CuBrHBr, right? And here if you have Ki and you heat it, this is not a Sandmeyer reaction, okay? This is a different separate reaction. If you, from disonium salt, if you want to prepare idobenzene without adding any oxidizing agent, you can just prepare it from disonium salt. You can add Ki into it and you will have the formation of idobenzene. Here you can have the formation of chloro and bromobenzene. This is Sandmeyer's reaction. These two are Sandmeyer reaction, okay? What is Gattermann reaction? When instead of salt you add simply copper. So here copper in presence of HCl, copper in presence of HBr is added, right? Chloro and bromobenzene is formed here. Gattermann reaction this is, right? Now what is Bals-Schiemann reaction if you want to prepare the fluorobenzene from benzene disonium chloride? Just add HbF4 and heat it. This will be replaced by fluorine here, right? That is called Bals-Schiemann reaction. This reaction we have already done, that is Hans-Dicker reaction. From carboxylic acid salt, silver salt of carboxylic acid, bad criminals at a very high temperature, bromine CCl4. What will happen? This will be replaced by Br. This whole thing will be replaced by Br. Carbon dioxide will be released and AgBr will be formed for the preparation of bromides only, right? This is for bromides only, right? Okay. Now, next is the reaction of haloarenes, right? Okay. Okay. Ashwath, I know that. Okay, I know that. Reactions of haloarenes. Now, let us see the reaction of haloarenes. Nucleophilic substitution reaction with metals and electrophilic substitution reactions. So, first is your nucleophilic substitution. Nucleophilic substitution means you need to substitute this X to some nucleophile, which is a very difficult thing to do. Can you tell me why this is such a difficult thing to do? Because in the resonating structure, you have double bond character in CCl bond. In the resonating structure, right? Okay. RA is saying, ma'am, your voice is clear, action really doesn't matter. Yes, actions will be clear also. Thank you so much for the support, Arya. Now, let us complete this today, right? Now, if you can see this CCl bonds, they are double bonded. Like we can say partial double bond character. So, it is difficult to break this CCl bond. That is the first reason why CCl bond is so difficult to break. Why this nucleophilic substitution reaction is so difficult to occur. Second reason is this particular carbon is sp2 hybridized, right? But when we talk about simple CH3X, this is sp3 hybridized. This is sp3 hybridized. That is the reason in this case what will happen. sp, we know that the electronegativity is sps, then sp2, then you have sp3. Because of more electronegativity of this carbon, it is difficult to break this bond again. It will try to take the electron towards itself. That is why it is difficult to break this bond. Right? That is the second reason. Third reason is, even after it is able to break this bond and it forms this phenyl cation, this is not a stable phenyl cation. That is why it is very difficult to form this kind of compound. Right? That is very difficult to break CCX bond here. Right? So, here we have given the reason, difference in the hybridization, double bond character, right? Greater S character, greater electronegativity. Here the electronegativity is just, it is difficult to break shorter bond than the longer bond. It is having double bond character, that is why bond is shorter. There is no double bond character, bond is longer, right? Okay. Third reason was instability of this phenyl cation, right? Phenyl cation will be formed, but that will not be stable. So, why it would try to break the bond? If after breaking the bond it is not stable, then there is repulsion. They are saying that on this halogen you have electrons, 3 electron pairs you have. Then this nucleophile is also this is also having a big negative charge. That is why this electron density and this electron density will repel each other. That is why the nucleophilic substitution reaction is very difficult here. We need some like really good conditions to have this kind of reaction, and that condition is preferred, that condition is justified by Dow's process, that is having 623 Kelvin temperature, very high temperature, and a very high pressure of 300 atmospheric. So in Dow's process, what you have, this Cl is replaced by ONA firstly. After the acidification, right, what will happen? This ONA positive is replaced by OH, and hence you will have the formation of phenol here. Benzene will be the intermediate that is formed here, right? Okay, so what you need to understand, that it is having at a very high pressure, high temperature it is occurring. Now the question that is asked to you is, what if we have an electron withdrawing group at ortho, para or meta position? What will happen here? For that you need to understand one thing. Firstly, let us go through the mechanism here. In the mechanism you have the formation of benzene, right? Benzene is formed in the mechanism. Benzene reaction intermediate is formed in the mechanism. Firstly, base will try to abstract the proton, and there will be one negative, like that means there will be 2 electron pairs that are involved here. Now these electron pairs will jump to this one and Cl will be taken out here, and hence you will have the formation of benzene. After benzene, which is a very unstable thing, again OH negative will attack here, but as a nucleophile now. Now it will attack as a nucleophile. Now it will attack as a nucleophile. Here it is attacking as a base, because it is taking out H positive. Here it is getting attached there. It is acting as a nucleophile. So it is acting as a nucleophile here. Then what will happen? Again, here you will have the negative because electrons have jumped here. Because of this positive, acquired positive here, nucleophile has attacked here, right? Now, to this negative, what will happen? Electrons will, see, basically what we need to do, ONA, right? So what will happen? Electrons will jump here and that H positive will shift to this side. Internal shifting will happen. This is your H. Now you have O negative, and now Na positive will attack here. You have ONA. Now H positive will replace the Na positive, and hence you will have the formation of phenol. Important thing is the formation of this benzyne intermediate. That is the important thing. That benzyne intermediate is formed. They can ask you this question. Okay. Now let us see what will happen if you have on the meta or ortho position, you have the NO2 groups. What can happen now, right? So, see one thing here. We know that in the chlorobenzene structure, right, resonance structure, at ortho and para position you had negative. Electron withdrawing means that is going to take out the negative from that side. Now, if at ortho and para position you have electron withdrawing group, so it is going to decrease the electron density. So, if the electron density is decreasing here, it will be easy for the incoming nucleophile to attack here, right? Because nucleophile hates electron. So, if you are taking away the electron, it will be easy for the nucleophile to attack, right? Okay. Okay. Yeah. Okay. So now it is not easy. This is where this is NaOH. Wait a minute. This is NaOH. This is 443 Kelvin. The temperature, wait a minute. The temperature is low now, 443 Kelvin. Because on the para position, if you have attached a NO2 group, right, it is going to take the electron from the para position. When the electron density is decreased, nucleophile will be like, yes, less electron density, now I can attack here, right? That is why here the temperature will be decreased, that is 443 Kelvin temperature. Earlier we were having 643 Kelvin temperature. Here temperature was 623 Kelvin, right, around 600 Kelvin. Here it is around 400 Kelvin. That means it has decreased. We need less drastic condition. Now, if you have at ortho and para position, now the temperature is 368 Kelvin. That means the temperature is further decreased. The temperature is further decreased here. So, can we say that here also it will take out the electron? Here also it will take out the electron. So, temperature has been further decreased. And in this case, you have at ortho and para position, both you have this. That is why we just need to add NaOH and warm it, and you will get the product. And here the product is nothing but picric acid. NO2 at ortho and para position increases the reactivity of halogen, right? Now, if you want to see this with the mechanism, then you can see this here, that if you talk about, if you have NO2 group at ortho position you have this negative, and that is why this negative is taken out by this NO2 group. Hence, the electron density will decrease and hence the drastic condition will decrease. At para position also, you have this negative at para position, right? Electrons will be taken out by the electron withdrawing group and hence the reaction rate will increase, right? The drastic condition will be less. But if at meta position you have the NO2 group, there is ortho, you have negative, then you have para as negative, then again you have ortho as negative. This point where the carbon, where the NO2 group is attached, never had any negative charge, right? That is the reason there is no benefit, right? It will remain as it is. That is why there is no benefit of NO2 group at the meta position, right? Okay. Okay. What happened, guys? Looking for this chapter, so you're going live. I'm so excited, ma'am. Thank you so much, Apurva. What happened, guys? Is the voice like really? Is it not? Are you not able to adjust with the voice and this lag? Is this that bad? Huh? Is this that bad? Hanji, everybody in the chat box. Okay. Little bit your voice is breaking. Voice is breaking, is it? That's a new thing to me. I think I should destroy the studio now. Everything is clear? Okay. There is little bit of lag that I know. Like the team is working on it, guys. You have no idea like how much brain I have eaten for IT team. IT team is now fed up of me, right? Yesterday, the whole day I was sitting on video call with the IT team. I was like, why this is happening, that is happening, this is happening, right? Then they are sending the person to my home only. That this is not possible, ma'am, on video call. We'll send someone to your home. Because like something really bad has happened to this studio. I don't know what has happened here. I think the studio is not well. It's also suffering from cold and cough. Okay, now let us see this reaction with metals. Now with metals, again, this is fatigue reaction, right? What will happen? What will happen here? You have two phenyl, you can say haloarenes, right? Na you have in the presence of dry ether, NaBr will be eliminated and hence you will have the formation of diphenyl. Similarly, here also you can have the formation of, you have Woods fatigue. That means Woods you can say this by haloalkane. Fatigue you can name this by haloarene. So you have in Woods fatigue you have one haloalkene, one you have haloarene. So NaCl will be eliminated and hence you will have the formation of toluene here. Right? Okay. Now next is with copper. If you have copper, very important reaction, that is Ullmann's reaction. So when you have idobenzene and you have Cu, right, what will happen? CuI will be eliminated and diphenyl will be formed, right? So with the lithium, what will happen? If you have lithium, dry ether you are using, then again what will happen? This lithium will be, lithium will replace the Br here and phenyl lithium will be formed here, right? With lithium, this Br will replace this lithium and phenyl lithium will be formed here, right? And then you have magnesium. With magnesium, Grignard reagent will be formed. This Mg will come in between this R, this aryl group and this halogen, and here RMgX will be formed. That is your Grignard reagent will be formed here, right? Okay. Now let us see the electrophilic substitution reactions, right? So for electrophilic substitution reaction, some electrophile that will attack on this haloarene group, right? That means on this chloro, bromo or halobenzene. Now we know that in this process, because of the resonating structure, electrons are donated here, it is donated here, then it is revolving throughout this group, right? Throughout this pi bonds, right? This delocalization is happening throughout this cyclic ring. That is the reason this throughout this ring you have delocalization of electron. That is why this is having a very good electron density throughout the ring. That is why electrophile is attracted toward it and it will show all the electrophilic substitution reactions. But the question is it para-directing, is it ortho-para-directing, is it meta-directing? Because it is showing plus M effect. That is the reason it is ortho-para-directing, right? That is the reason it is ortho-para-directing. But a very important thing about haloarenes, or you can say chloro or halobenzene, is that it is ortho-para-directing because it is showing two things here. It is showing plus M effect, okay, and it is showing minus I effect. Minus I because halogen is electron negative in nature. So it will show minus I effect. Plus M because electrons are donating. It is donating the electron due to the lone pairs here, right? But in this case, something weird will happen. Always throughout the organic chemistry, I'll tell you mesomeric effect is stronger than the inductive effect. But only in this case, I'll tell you that inductive effect becomes more stronger. That is why this is the exception. That is the reason it is ortho-para directing, because it is showing plus M. That is why it is ortho-para directing. But it is deactivating because overall it is electron withdrawing group. Though it is showing plus M effect, but it is a deactivating group. That is why the reactions, electrophilic substitution reactions, are not fast. Here the electrophilic substitution reaction are slow only as compared to phenol. Because phenol is also showing phenol also show minus. If you have phenol, if you talk about phenol here, it also shows minus I and plus M effect. But here mesomeric effect is stronger. So it is an activating group only. It is activating, it is increasing the electron density in the group. Right? So that thing is very, very important for you guys. Okay. Yes, guys. Okay, everybody. Now, here as you can see here, this is your benzene and halogen. As I told you, it is very electronegative, hence decreases the electron density, hence it is a deactivating group because minus I effect is greater than plus M effect. Right? Okay. Now, let us see what will happen in the electrophilic substitution reactions. So, basically, this is a mechanism that is happening everywhere. So, what will happen? Electrophile attack on any of the pi bonds, right? Then electrophile will get attached here, right? Hydrogen will be attached. E positive, that means there will be one negative, one positive here. This is attached to the negative part, and here you will have one more hydrogen, and hence this thing will be formed. Now, resonance will occur, pi bond will shift here, then again pi bond will shift here, then again you will have this kind of structure. Now, in the end, once you have resonance, this is also resonance, H positive will leave and the electrons will shift here, and hence you will have the formation of this compound. Similarly, you will have at the para position also it can attack similarly, and you will have the same kind of resonance at the para position. Usually para product is more major because in para you have the symmetry, right? Whenever you have the para group, that will be symmetrical, right? That will be symmetrical. That is why para is always the major product. But if you have any hydrogen bonding on the ortho position, then ortho will be the major product, right? Now, next is this one. If you have anhydrous AlCl3, right? This is benzene, this is chlorine, this is this. See, simply same mechanism. So, just remember the electrophiles here. When you have anhydrous AlCl3 and Cl2, you have, this is the electrophile. It will attack on the ortho and para position, para being the major product. Then if you talk about the next one, concentrated HNO3, concentrated H2SO4, here again electrophile will be NO2 positive. Ortho and para will be formed, para being the major product, right? Then if you talk about the next one, concentrated H2SO4. Again you will have the SO3H. Here you have neutral electrophile is formed. Neutral electrophile. Right? It will attack here. Then it can have ortho or para position, but para will be the major product that will be formed here. But in this case, okay. Guys, I am from that generation where there was no JEE mains or advanced thing happened, right? And I didn't give the paper for JEE mains or advanced because see, I am from that city where still I don't have any like institute. Like in my city, still I don't have any institute which is teaching IIT or maybe NEET or anything like that. We just had private tuition. I had no idea there was something like, at that time there was AIEEE, but I had no idea about it. And my teachers were telling me that do BSc, then MSc, then PhD. That I thought this is the only option that I have, right? And my parents used to think that after engineering, we have to go to factories and we have to do that civil engineering job. So they were like, this is not for girls. Like, so this was the whole scenario when I was of your age. I used to think that all the people who do engineering, they go in some factories and they have to work. I had no idea what is MNC. I had no idea about the packages because there was no YouTube at that point, right? So that's a funny story that I had taken non-medical because I liked physics, chemistry and math, but I had no idea, right, that what is like AI-EEE. I knew that there was some exam AI-EEE, but I was like, okay, maybe that's, like everyone around me was so orthodox that they told me that that is not for girls, that is for boys, because there you have to go and visit the sites and do civil engineering jobs. So that was the thing. Then as when I grew up, I was like, okay, MNC is not a factory. Then why I was thinking like that? What was that scene in my head, right? So yeah, that's a funny thing. I really wish I was born up in a generation like yours, where you have everything. Like you have everything. You have YouTube. You have all the resources. But for me, it was a totally different scenario. So I'm so happy that even those students who are from a very small town, they can, they can afford free coaching also through YouTube. I'm so happy about it. I'm so happy that I am also among those teachers who are teaching those kids who are maybe not in a very big city, who are not maybe not whose parents are not able to send them away from them, right? So yes. Now let us see this thing. Friedel-Crafts alkylation reaction, as you can see here, this is CH3 positive. This kind of this kind of electrophile is formed here. This is a Lewis acid, and hence ortho and para product is formed, para being the major product again. Then Friedel-Crafts acylation reaction. Here CH3 C double bond O positive. This kind of electrophile is formed. Ortho and para position, again para being the major product here. Right? Okay, now let us do the questions. Okay guys? Chalo. Very nice Arya. Congratulations. Now, thank you Rohan. I hope so you liked it. Yes. So I talked about that thing also there, that was a tragedy of my life. But I'm happy. I used to feel bad when I went to college. After college, I got some idea that there is something called, like, BTech is actually not that bad. Okay, there are MNCs and they don't, it's not like you have to, at that time, if you remember, there was Nirbhaya case in Delhi. I was like, my parents were all ready. They were like, okay, we'll send you to some good city and you can study there from some coaching. But when I was in 11th class, there was this Nirbhaya rape case that happened. And at that point, my parents got so much scared. They were like, we will not send you away from the home because that is not safe. How can we send you to Delhi? You are like, you have not went, like, not even like you have not stayed in some relative's place also. How can we be sure that you will be safe in Delhi? So then I was like, okay, maybe they are saying so, that is the right thing. And I was also scared because of that. I was like, okay, so that was a very big thing at that time. And unfortunately, at that point, I was in 11th class. I was about to go, but that dream shattered there. So I was like, okay, maybe like, okay, I should stay at home and study at home only. Right? So yeah, that was something. At that point, I know today it feels like, okay, fine, ma'am, that was not a big deal. But at that point, it was a really big deal. For for parents, it was also a big deal. Like, how will we be able to manage that you are safe or not? Right? There is no relative in Delhi. How you will be able to manage everything on your own? So just stay at home, just go through these tuitions only and study. Right? And there was no YouTube. Nothing was available online. So that point I was like, okay, so this is my fate. This is what I have. This is what I have. So I found my happiness there only. Ki, okay, this is what my life is, and I have to make the best out of this. So I tried. Right? Okay. Yes. So yes, sometimes things happen. Chalo. Now let us do the previous year questions of JEE, right? Don't feel, ma'am, God give you the best. Yes, definitely God has given me the best. I think even if I have done BTech, no, even then I would have been teaching only because I love teaching. I found out it then at a very when I was doing BSc, I was teaching my juniors only. I started teaching at a very early age, right? So when I was teaching my juniors while doing B.Ed, I was teaching like BSc students. In that point, I realized that this is what I like. This is what I want to do, right? So I am thankful to God that whatever happened happened for the best, right? But still I have this feeling, what I wanted to give this exam, right? So still the little me, the 16-year-old me has this thing in that, okay, what if uh, I did that thing, what if, like that if is still there. But I'm very happy at what position, at whatever I'm doing, right? Because I know that I am very passionate about teaching. I love this, that I am doing what I love, right? I am not just following the crowd, I am doing what I love. I'm so happy about it. Chalo. Now let us do the previous year questions, okay? Let us do the previous year questions. Huh. Now let us see. Identify A and B in the following sequence. Right? So the questions are not very difficult, very easy questions you have here. Right? A and B in the following sequence of the reaction. You have to identify A and B here. So if you talk about Cl2H mu, that is a free radical mechanism. Right? What will happen here? A will be equals to, this is your benzene, or I can even write it here. A will be equals to, this is benzene, right? This is benzene, this is benzene, right? And here CH2Cl, right? It is replaced like this, okay? It is replaced like this, CH2Cl, right? Okay? Benzyl chloride is formed. This is formed, this is not formed, this is not formed, this is not formed. So definitely the answer is C only. After this, if you do the hydrolysis, then what will happen? Benzaldehyde will be formed. That means this thing will be formed. So answer is C. Okay? Okay. Yeah. Now this C thing will be formed, that is benzyl chloride and benzaldehyde will be formed. Right? Okay? No, Kapi, you are on time. You're absolutely on time. Don't worry. Now, C2H5Br alcoholic KOH. Right? I want you guys to try the questions, okay? C2H5Br alcoholic QH. Alcoholic QH means alkene will be formed here. So that means A will be alkene, that is C double bond C, and this is H and this is H, this is H and this is H. This alkene will be formed. After this you have the addition of Br2 here, CCl4, which is the anti-addition, right, which is the anti-addition, and hence you will have the formation of this kind of product. This is HHBr, this is again H, anti-addition it is now. So this is Br, this is H, this is H. So this thing will be formed. We have A or we have B also. Then what is C? After this you need to add KCN here. So Br will be replaced by KCN, means this is positive, this is negative. Ionic it is. So it will be bonded via C. Right? So answer will be C, this is C, this is Cn. This is H, this is H, this is H, H, and this is Cl. We have C also. After hydrolysis, what thing will be formed? After hydrolysis, see, this is C triple bond N. This is also C triple bond N. Right? So which thing will be formed? You will have CH2 COOH, basically CH2COOH, right? This is CH2COOH, right? Okay, just give me a second. Oops. I think succinic acid will be formed here, right? Let me see. What do you think, guys? Just give me a second. I think succinic acid should be formed. Because after hydrolysis, C triple bond N is converted to COH, right? So here this will be COH, this will be COH. So succinic acid should be formed. Let us see what is the answer. Yes, B is the correct answer. So succinic acid is formed, right? Okay, guys. Okay, everybody. Right. Now, this question we have done. Next, this also we have done. Next is this one. Okay. Next is this one. Aryl halides cannot be prepared by replacement of hydroxyl group of phenol by halogen atom. It cannot be prepared, that is a false statement. Cannot be replacement of hydroxyl group by halogen atom. Phenols react with halogen acids violently because they can be prepared by Dow's process. It's not like they can never be prepared. If you use drastic condition, it is possible. Phenols react. This means they are saying that phenol cannot be prepared by replacement. Acha, phenol to this one. Phenol to halogen. This is to aryl halides cannot be prepared by replacement of hydroxyl group by phenol by halogen atom, right? This means from this to this. Then you have phenols react with halogen acids violently. Phenols react with halogen acids violently. First statement is true, right? Aryl halides cannot be prepared, right? And second statement is false. So I think C should be the correct answer because they are not telling about from this to this. This to this can be prepared, but phenol to halo is difficult to prepare, right? So that is why I think C should be the correct answer. Yes, A is true and R is definitely the false one, right? Okay. So next one is, this is so very simple. Alkyl halide is converted to alkyl isocyanide by reaction of which thing? Alkyl halide to alkyl isocyanide. Iso means NC. NC means you need to see AgCN here. Because AgCN, C is not free. It will be bonded through N, right? So here the answer will be D, right? Okay. Ma'am, how? Because this is a statement they are telling. From this to this is definitely difficult to prepare, right? Difficult, it is not possible to prepare this, right? So OH will be replaced by halogen. It is a difficult thing to do, right? You have not seen this kind of reaction, right? We have seen the opposite reaction from halogen to when we replace halogen with OH, that we have seen, but this reaction we have not seen. Right, so that is the true statement. Phenol react with halogen acids violently. HCl, HBr, HCl. Have you seen the reaction of phenols with HCl, HBr? No, right? So they don't react violently. Right, so this is a false. This is basically not from haloalkanes, haloarenes. This is a question from phenols. This is a question from phenol ether alcohol. Right? So I think by mistake it is here. Right? Next one is the final product A formed in the following multi-step. See, first step is Mg ether, then CO2. Okay, then you have NH, then you have Br2. Very nice, very nice, very nice. So when you have MgBr, so it will be like this. Okay, if you have MgBr, it will be like this. then you are adding CO2, right? If you're adding CO2, it will be something like this. See, all the reactions you should know, right? So what will happen? This is partially positive, this is partially negative, this is partially positive, this is partially negative. So this is going to attack here. This is basically C, and this electron is going to jump here. Double bond O, this is O negative, this is MgBr, and here you will have the attachment of Br. After hydrolysis, it will become OH. That means benzoic acid will be formed. That means here you will have the formation of benzoic acid, right? After this, you are adding what? You are adding NH3 ammonia and heating it. When you add ammonia to benzoic acid, it will get converted to amide, that is NH2, right? So it is get converted to benzamide. Benzamide is formed. Then you add Br2, NaOH. This is nothing but this is Hoffman. This is Hoffman bromamide reaction. Yes, Hoffman bromamide degradation. So what will happen if you have CONH2? You add Br2 NaOH. What will happen here? We have done this in amines. What will happen after this? This CO will be eliminated and you will have this NH2 will remain here. So you will have the formation of this aniline. So B will be the correct answer. Okay? Hello Akash. Yes. So B will be the correct answer, right? Okay. Next one is the correct order of reactivity in electrophilic substitution reaction for the following compounds. Okay. The correct order of reactivity of electrophilic substitution reaction. That means how much electron density is there. So see, when you talk about CH3, it is going to give you the plus I effect. It is going to show plus I effect. It is going to show plus I and it is going to show you minus I and plus M effect. It is going to show you minus I and minus M effect. So definitely this is here minus effect is dominated. So very important question it is. If you don't know that minus effect is dominated, right? See, A is having only activating effect. Right, here the overall effect is both are minus, here also minus I, minus M. So it is a deactivating group. This is also a deactivating group. Why? Because here minus I effect is dominated. And this one is having activating. So which is activating? That means increasing the electron density will have the maximum. B is having the maximum. So these two are eliminated. Then you have A or this. Definitely A, because A will have no effect. These are deactivating. Deactivating means decreasing the electron density, lowering the rate of reaction, right? So definitely it will have A after this. Then you have C and D, right? Okay, then you have C and D. Okay, everybody, then you have C and D. Guys, just give me a second. Okay, just give me a second. Okay, so sorry. Yeah. So now this is having the maximum. B will be maximum. Then you will have A. Now what about after C and D? D will be more or C? Here so we can see that D is the correct answer. But why C is more as compared to D? See, C is less deactivating as compared to D. D is having two minus effects. It is having only one minus effect which is dominating. So definitely here C is having less deactivating effect, but D is having more deactivating effect. That is why this will become the correct answer, right? Okay. Then this is the next question, that is, you have identify the correct set of reagents or reaction condition X and Y in the following set of transformation. So here you have X, you are having a product, Y, you are having this product, right? Okay. So if you add dilute aqueous NaOH, then Br will be replaced by OH. And on adding any other group to OH, alcohol, you won't get Br here, right? So if you want to, this is on the first position, this is on the second position, that means here it should be alkene, right? So if you add alcoholic, not dilute, not aqueous, if you add alcoholic NaOH, then you will get the product as alkene, and that is your CH3, CH double bond CH2, right? This is what you will get. That is the alkene that you will get. For this alkene, if you add Br2 CHCl3 or you add HBr acetic acid, definitely HBr acetic acid is going to give it Markovnikov rule. Markovnikov rule will ensure that the negative part is on the less number of halogens, and hence this product will be formed. So answer D is the correct answer. Right? Very good, shabash. Very good, very good. D is the correct answer. This also we have done. Then we have also done this one. Oi hoy. This we have done, na? Yes. Now, this is a very, very important reaction. Right? As you can see here, ClBrNaEt twice O. Okay. This is nothing but this is ether. Can you see this is ether? Et twice means like this. You'll get confused, ma'am. Nothing, I never seen that reaction, ma'am. Arey, that is ether. Okay, that is ether. Dry ether, Na. So it's a Woods reaction. So what will happen here? Firstly, A will be, this will double, free radical mechanism, this will double, and here you will have Cl, and here you will have Cl. That will be formed, right? That will be formed. After this, if you add CuF2, this is inorganic fluoride. This is Swartz reaction. Can you identify that? Swartz reaction. So C will be, after Swartz reaction, this will be replaced by fluorine. Fluorine and fluorine. So first is your C is fluorine, right? C is fluorine. Oi hoy, this will not be the answer. This will not be the answer. Either this or this. So A and B are eliminated, right? A and B are eliminated, right? Now you have MgEt twice and D2O. MgEt twice means here what you are going to do. Here you are going to make the Grignard reagent, then doing the hydrolysis, right? Grignard reagent, then doing the hydrolysis. What will happen? After Grignard reagent, see what will happen here. In the B part, what will happen? Grignard reagent, that means here you will have MgCl, here also you will have MgCl. Whenever you add water to the Grignard reagent is very reactive towards water. So this Mg will be replaced by the water, and here the water is not H2O, it is D2O. So it is D and D. So here the answer will be D is the correct answer. This will be the correct answer. Okay, this was a good question. Okay, D is the correct answer. Okay, D will become the correct answer. Right? Okay. Next question, D will become the correct answer. Next you have KCN, alcoholic. See, KCN alcoholic, that means everything else will remain same. It's just that this Br will be replaced by KCN and from C, right? So it will be, everything else will be same. There will be replacement of this C and only. So D is the correct answer. Everything else is same. There is just replacement of this Br with C. Don't feel that, okay, ma'am, question should be tough. How they can ask such a simple question? Okay, nothing else will change here. KCN alcoholic, they are asking this question so that because students get confused. AgCN here, in that case, if it is AgCN, then in that case it should be NC. But here it is KCN, so it should be CN. Everything else is same only. Right? Okay. Now let us see 2-3 problems of advance. Also advance, I'll going to start, right? Don't worry about that. We'll start practicing more of the advanced questions, right? But right now my focus is on your means and giving you hint of advance, that what is asked in advance, right? Okay, we'll do specific sessions for advance as well. So correct statement for the following addition reaction. So this is what I told you, that in advance, like more depth questions are asked, okay? So here we know that this is trans. Trans means negative. Here it is cis. Cis means positive. Br2CHCl3 means it is anti-addition. Anti means negative. Anti means negative. Negative will form positive. That means erythro compound will be formed. That means you will have CH3. I think this question we have done also, right? Erythro will be formed. That means Br on same side. This is H and this is H, right? Now, when we are saying that positive and negative, that means thero will be formed. That means thero will be formed, and here you will have, this is CH3. CH3. Thero means Br on the opposite side. This is hydrogen. This is hydrogen. Right? Okay, this is hydrogen, hydrogen. There's 2 questions, guys. 2 questions left. My legs are also paining right now. I've been standing here for like last 6 hours. Now, this is M and N. They are saying that this is M and N. Mn means what thing? Mn means what thing is formed here. This one and this one. This thing is formed, and also one more mirror image of this. That means H. Mirror image will be formed also, no? HH, Br, CH3, CH3. 2 kind of erythro can exist. And here also 2 kind will be formed. This is CH3. Mirror image of this will be Br, H, Br. Okay, these 4 compounds will be formed. This is your M, this is N, this is O, and this is P, right? MO, NP are 2 pairs of distereoisomer. MO and NP. What are distereomers? That are not the mirror image of each other. These are called distereomers, which are not mirror image. Now these 2 are non-superimposable mirror image. These are enantiomers. My hands are enantiomers. Right? For example, I have 2 things which are not even mirror image. They have the same atoms, but it is not mirror image of each other. So, M and O are not mirror image. You place them together, they are not mirror image. This is also not mirror image. So, can I say this first statement is true? Can I say this is true? Everybody, can I say this statement is true? Bromination proceeds to trans addition, means anti-addition. Can I say this is also true? That's why I have made these products. Right? That is also true. That is also true. 2 statements still here are true. They are asking you how many statements. Ortho and para are identical molecules. Oh, sorry, ortho and para. I am saying O and P are identical molecules. Are these 2 identical? Identical means if we place this here, that will be superimposed mirror images. If I place this here, they are not superimposable. That means they are not identical. So this is false. This is false. Okay. Next is MONP. What is MO? MONP are 2 pairs of enantiomers. Enantiomer should be at least mirror images. MO and NP, they are not mirror images of each other. Non-superimposable, we will think if they are mirror images. So this is also false. So this is also false. So I guess first and second are true. Yeah. So first and second are true. A and B are true. Okay. Understood this thing, guys? Everybody in the chat box? Understood? Thank you so much, Rathi. I have just started, right? I am just giving you a hint of JEE Advance, right? Don't worry, I'm going to do like big sessions on JEE Advance when the time is right, okay? So now I am just telling you that why what I have taught you is important. Students usually think that why ma'am is teaching this anti-sin, why? Because it is asked. They are asking you these questions, okay? Understood? Now, next is in the following reaction, they are saying that in the following reaction, the major product is major product. Now, this is a simple question, okay? This is actually a simple question. One equivalent of HBr you are using. That means only one double bond we will break here, right? This is 1, 2, 3, 4. Here, one 4 addition product can be formed, right? So, what can happen here? This is basically what we can do that what can happen here? This double bond can jump here. This is C double bond. Instead of this can be C. This is CH3. This is double bond. This is C and this is CH2, right? We know that here it is CH2 and here it is CH3, CH3. Now 1, 4 addition product means here at one point you can add hydrogen, that means hydrogen, and here you can add Br. That means here what we can have, here it will be Br will be added and here hydrogen will be added, so it can be CH3. So this product will be formed. CH3, CH, double bond, C, CH2, CBr. So D will become the correct answer. So 1, 4 addition product. 1, 4 addition product is formed, right? When you have alternate double and single bonds, then alternate double and single. You have formed 1, 2 addition product. 1, 4 addition product is preferred because of the conjugation, right? Okay, so this double bond will jump here. These electrons will jump here. Hence, you will have a positive here. This will be CH2. This is positive. This will be CH2. This is negative. Then you can add this. This is not the mechanism. I am just showing how to do it in an easy way, right? Okay, how to do it in an easy way. This is C. This is C. So, this is to this negative. You will have the addition of Br and here the addition of H, right? Okay. So, wait a minute. Okay. Okay, so D will be formed here, right? Okay, so D is the correct answer. Okay, guys? Ma'am, I am feeling hungry. Yes, you are feeling hungry at the very right time. Okay, so guys, that was about haloalkanes and haloarenes. Now, some of the things I have taught you in a very speedy manner here, right? So, I think I have done justice only, but Wood's reaction, all these things. Now, why I have not taught you Wood's reaction here? The reason is because I'll teach you those things in hydrocarbons, okay? So, there is a full-fledged hydrocarbon is a very big chapter. That's why I'll take two parts of it. One is alkanes and alkene, other is alkynes and aromatic hydrocarbons. So, in the first part, even if I am not teaching you the questions, okay, it's not that you can miss that part, right? Because hydrocarbon will form the base. I know we are going in a reversed manner, right? But still, I am trying my best so that we together can do whatever was left. Also, you can write down the chapters that you want me to do next. Okay, now I am thinking, and what you want? Do you want previous year question? Do you want practice? Do you want theory? Right? Okay, so because if you want really a lot of questions, then there will be a different session for questions only, right? Because with theory, having the question, it will become really, really long. As you can see, I have just picked out few questions and still the lecture is really long. And even I was not writing the theory. I had pre-prepared slides. Even then the lecture is really long. Because I can't just read here and go. I need to make you understand what I am teaching you. Right? Okay? Understood? Chalo. Okay, thank you so much, Rohan. Thank you so much. When is the next class? Next class is, I think, wait a minute. Let me see the schedule. Just give me a second. Just give me a second. The next class is on Thursday. Thursday 5 p.m. Okay. Next class is on Thursday 5 p.m. Definitely, Vanish, we will do that all naming reactions, all mechanisms, all reagents in one go. We will do all of those things. Okay, don't worry about that. Chalo. Okay, then bye bye. Take care, ma'am. My name is Diksha Kaushal, and you can connect me on Diksha__Kaushal. That is my Instagram handle. And you can also connect me on my Telegram channel, that is Diksha Kaushal Chemistry Official. Okay, bye bye. Take care. See you all in the next class on Thursday. Bye bye.